The demand for data engineers is growing rapidly, and you need to master this skill to actually crack the interviews. I'm not talking about cloud because even cloud developers fail in this area. I am talking about data warehousing. So in this 3 hours long video, you will learn everything related to data warehousing from scratch, including ETL layers in data warehousing, incremental data loading, CDC timestamp, dimensional data modeling, star schema and Snowflake schema, fact tables and dimension tables. Not only this, we also want to cover some deep topics such as transactional fact tables versus periodic fact tables, what are degenerate dimension tables, difference between role playing and junk dimensions, and finally learning all the types of slowly changing dimensions and implementing it with code. This ultimate guide is a condensed form of knowledge provided by this book, The Data Warehouse Toolkit by Kimball. And trust me, this book is a gem. And do you know why this video is also a gem? Because we gonna cover all the concepts with practical implementation. So just take out your notebook and start learning this in-demand skill and crack your dream job in 2025. So what's up, my data fam? What's up? How is your Sunday going so far? So today's video is very special. Why? Because this particular video is for everyone who comes in the list of everyone. So let me just tell you. So data warehouse, the ultimate guide. So the thing is, if you are an aspiring, if you are an aspiring data engineer, this video is for you. If you are already, let's say, a data engineer, still this video is for you. If you want to excel in the world of data engineering, this video is for you. Why? Because data engineering's most important area is data warehousing. Either you are using Azure, AWS or GCP, either you're using on-prem or cloud data engineering, you are doing anything in the world of data engineering, this area is the most important area which is everywhere. And trust me, this is the area where people actually lack in the interviews as well, because when interview asks you about the data warehousing, people know like how to use tools, but they feel stuck whenever someone asks them regarding data warehousing, regarding data modeling. So this is the area that you need to master, and this is the area that will obviously give you an extra edge over others, because this area is the most basic and the most important one. Plus, it is not easy to master this. Data warehousing is the basis of the data models existing right now, like in the whole world. So it is not easy to master. So if you think that you already know data warehousing, just think twice, bro. Just think twice. So if you want to know like how to just build data warehouses, what is data warehouses, you do not have any knowledge, this video is for you. If you still have some knowledge, you know like what is a data warehouse, what is blah blah blah, but still this video is for you. Trust me bro, because I have just covered everything in this video. Just a disclaimer, this video will not only cover the theory. No, this video will actually show you how to build dimension tables, fact tables, incremental loading, everything. So we will be actually doing it. We will be learning by doing it. Okay, so we will be obviously covering concepts first. We will be looking at like architectures, like how things are working behind the scenes. Then I will just show you practically as well, like how to do those things. That is why this video is special, because whenever you are just reading books, you will not actually see how to implement that. So I will be using latest tools and technologies to actually build this and actually make you understand how things are working in the industry. Okay, very good. Now you'll be asking what are the prerequisites. Nothing bro, just an like just excitement to learn data warehousing, just excitement to grow in the world of data engineering. That's it, trust me. So this is the ultimate guide, data warehouse, the ultimate guide. And after watching this video, you will definitely master data warehousing, because you know me, right? You know me. Like, I will just make you understand everything, everything, everything. I know, like, this topic, this particular area is really, really confusing. Why? Because it is confusing, right? Because it is a complex topic. But now, today, you will master it. You will master all the things related to data warehousing, and I'll be covering so much, so much, so much, so much in this video, that even if you just know a lot of things in data warehousing, still you will feel that, hey, this was new. Hey, this was new. So that is why. So I am really, really, really excited to get started with this. You do not worry about tools and technologies, like what tool we'll be using, what technology we need to install. Do not worry. I'm here. I will tell you everything along the video. Okay. So do not worry. Just take out your notebook. Just obviously you have your laptop on. If not, just take out your laptop right now and just actually get started with this ultimate guide and learn the skill and grab the offers in 2025 with confidence. Okay, let's get started. By the way, there's a good news that I have finally enabled the join button on my channel. So if you want to become a loyal data family member and want to support this channel, and if you genuinely feel that you get the knowledge, like the precious knowledge in the world of data engineering, where people are charging thousands of bucks, and you generally want to just support this channel because you are getting much better knowledge than those highly paid courses, so that obviously you can just click on this join button. You can just support this channel so that I can just create more and more videos. Obviously this will motivate me a lot. So just click on this join button and just join my loyal data family member family base. Okay, so let's get started. So first of all, let's try to understand what is a data warehouse. Let's start from the very scratch. Let's start from the scratch and let's try to master it. First of all, first of all, what is a data warehouse? Everyone talks about data warehousing. If you just see any company's job description, they will definitely write, hey, you should have the knowledge or experience building data warehouses. You will see this word. This is the most popular word in the world of data engineering. What is it? Let's try to understand. This is very, very simple. So data warehousing, by the way, just take out your notebooks because I'm just writing the notes for you so that you can actually create notes and you can actually just try to gain knowledge and you can just revise it in future. Okay, so basically data warehouse is a central location to store every single data. Data warehouse is the central location, or you can say central repository, where organization stores all the data, all the information. Just take an example of any data, any information. Let's say company made any sale, so data regarding transactions. Okay, data regarding, let's say, sales, data regarding, let's say, budget, data regarding, let's say, marketing, or let's say then HR. Everything, every single piece of data will be stored in the data warehouse. So if you want to see like how much data that we have, like what is the total profile, what is the total data that company or organization is holding right now, that information can be tracked using this particular data warehouse. Data warehouse is nothing but, it is your, let's say, a bag. Okay, your luggage bag, where you just store every single piece of your, let's say, outfit, if you are just planning to going on vacation. So all the pieces, like every single type of your outfit, everything will be there. Maybe it can be your formal clothes and informal clothes and party wears, everything, everything, shoes, socks, everything, right? Make sense? So data warehouse is nothing but, you can say, this is the central hub, this is the central repository. We have all data stored in the data warehouse. Simple. Make sense? Make sense? Make sense? That was just the high level overview, very high level overview. Now, if you are a data professional, if you have already let's say run some SQL queries, obviously if you are just a data analyst or business analyst or even a data scientist, like anyone, you know a little bit about data, little bit. Even let's say you have just explored some Excel files, right? So you know that databases exist. And I'm so sure that you would have heard about these words such as MySQL and MS SQL Server, okay, PostgreSQL. You would have heard these words, right? What are these? So basically, these are your SQL database workbench, where you just store databases, where you just manage databases. Okay, so what is the difference between a database and data warehouse? Very good question. Let me just show you what's that. So my next topic is database versus data warehouse. What is the difference? And obviously, if you're just learning data warehousing for the first time, that should be your first question. That was my question as well. Because I was relating this data warehouse term with database, and I was saying like, hey, I used to just query databases like select asterisk, tuck, 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 and I was just getting the result. But what is a data warehouse? What is the application name where we just keep the data warehouse? Like, what is that? So the thing is, MySQL, PostgreSQL, and MS SQL Server are DBMS, database management system. Okay, so they manage databases. They manage databases. Okay, but what if I tell you that we can also store data warehouses in those workbenches as well? How? That is just DBMS, right? So the thing is, data warehouse or database actually stores data, let's say in the form of tables and columns, right? Like in the form of rows and columns. The only difference between both is, let me just share, it's not about using an application. You can obviously store your data warehouse in MS SQL Server as well. And you would have also stored your DB, like database, in MS SQL Server. So that is not the difference. That is not the difference. The difference is how we actually store data within the database or data warehouse. How we push the data between these two different architectures. Let me just tell you. So this is your database. Okay, this side is your database. Okay, this side. This database will be storing data in the form of transactions. Okay, let me just write it for you. In the form of transactions. Okay, what are transactions? Transactions can be any form of data. Let's say your company is a fintech company, let's say, and they are just dealing with transactions in the form of credits and debits of money, in and out of money. So all those in and outs, all those interactions, all those things will be stored in small chunks, small chunks. Whenever a person is let's say putting some money in the application, it will be stored here. Let's say a person is pulling some information, or let's say pulling some money from the application, it will be stored here. So information is stored in the form of small chunks, in the form of transactions. Okay, so this is a kind of your near real time data, because every time a transaction is made, it is stored automatically within just few milliseconds. Within just few milliseconds. This is your near real time database. This is your near real time. Okay, this is your database. Now what we do, we know that we have all the information here, like talk. Now you would say, we have all the information here, all the information here. Why do we need to have this data warehouse then, when we have like all the information stored in our database? Very valid question. Very valid question. So the thing is, this database is constantly interacting with the source, constantly. Okay, so now just tell me this thing. If you want to build reports, if you want to build visualizations, dashboards, Power BI, Tableau, all those things, if you want to build just, if you just, let's say if you just want to do reporting on this data, Obviously, bro, that's why we are just saving this data, right? So that we can just use that data. If you want to build reports on top of this data, and if you just, let's say, query select asterisk from this table, okay, you just did this, okay, perfect, no worries. Now this particular SQL engine is busy with interacting with source, and it is constantly taking care of the data, like while pushing it and like just doing insertion of the data in just milliseconds. So that on that particular SQL engine, you are also using SQL queries. How it will be, let's say, how it will just keep the load balance. Like on one side, it is just trying to insert data that is coming constantly. On the other side, you are also asking it to just give us the results. It will not handle it, because it is impossible. It is not impossible, but it will just slow down the performance. Like it will slow down the performance to the next level you cannot even imagine. It will slow down the performance. And obviously now you're just building reports. Now let's say you want to refresh the dashboard and it will take 1 hour to refresh. What you will say? Obviously that's not a good practice. That's why what we do, we just load the data to the data warehouse. Load the data to the data warehouse. Okay, now you will say, Anjalamba, stay here. Yeah, I know your question. Now you will say, Anjalamba, you were saying that when we query the data from the database, performance slows down. So when we will be just applying transformations, let's say querying the data from the database and storing in data warehouse, what will happen? Why performance will not be degraded? So the thing is, what we do when we need to just put the data from the database to data warehouse, we use something called as ETL. Let me just write it for you. ETL. Okay. Where we do not apply transformations on the source side. We do not apply transformations on the source side. Okay. That means we just pull the data in bulk. In bulk. Let's say in bulk. So I will just pull the data in bulk from the database. Okay, let's say, so we know that this database will be inserting data, will be just receiving the data, let's say, in every second. So what we can do, we can just load this data every day at 9 p.m, let's say. And we will say, hey, whatever data you have received till 9 p.m, just give it to me. Just give it to me. Oh, it will say, okay. So now this data warehouse has the data till 9 p.m. This data warehouse has the data till 9 p.m. Okay, till today, like 9 p.m. today. Okay, okay, makes sense. Okay. So now when we will be querying data from this database, we will not apply any transformation. No. Any kind of filter, any kind of nothing. Nothing. We will simply say, hey, give us the data. Because obviously when you are just applying select asterisk, this was the basic, you can say, statement that I was using. Maybe someone is using calls function, someone is using window function, someone is using aggregation function. So in that particular scenario, it will not be performant, right? So that is the common sense. I assume that you are just imagining that what kind of transformation that I'm talking about. So okay, so now let's say we have the data till 9 p.m. Okay, makes sense. Next day this database received, let's say, 1,000 more records. Okay, now our data warehouse will say, hey bro, what's up? Database will say, hey, nothing much, you say. So this time data warehouse will say, bro, just give me the data after 9 p.m till now. Now means 9 p.m today. Today means like tomorrow, because this is now yesterday, because I'm talking about next day. So this will say, hey bro, do you have any new data? It will say, yeah, I have 1,000 plus records. It will say, hey, give it to me, give it to me, give it to me. This way it works. So data warehouse is a kind of, let's say, a big brother of database. It will just keep on fetching the data from the database. Okay, okay, and it uses ETL for that. Don't worry, we will be just talking about ETL in detail. So I'm just trying to explain you database and data warehouse in detail. This is the most detailed version of database as a data warehouse so that you can actually understand it. Because I want you to have like strong base, bro, strong fundamentals. Okay, so now this data warehouse will say day after day after tomorrow. Okay, it will simply say, hey bro, just give me the data after 9 p.m. yesterday till now. Now means today 9 p.m. So it will say, do you have any new records? So database will say, yeah, I received 500 plus records today. So it will say, hey, just give it to me. So now it is having data, all your data. Okay, but in static manner. Why? Because this will only be updated when we will be asking the new data from database. But on the other hand, database is near real time because it is constantly receiving data, right? Makes sense. So now all your data analyst, all your data scientist, all your business analyst, everyone who wants to use data for their reporting, for their decisions, they can simply query this particular data warehouse. They do not need to go to the database. They do not need to disturb the database because that particular guy is constantly receiving some data. So do not disturb him. You can disturb him. This is built to be disturbed. Okay. You can disturb him. You can simply say, hey, just run this query. It will just run your query. Then you will say, hey, just run this query. It will say, okay, let me just run your query. That's how it works. Okay. So database and data warehouse are not like different, so different things. No, the difference is how they receive the data, how they store the data. Okay, okay, makes sense. Now you would understand why industry is moving to cloud, because the size of data is so big right now that they need to just keep the data in the cloud. Okay, now you got the answer. Don't worry, we will be just talking about cloud data warehousing as well. Don't worry. Let me just, I think now you have understood everything. Database is a data warehouse. Now I think you understood everything. Okay, so okay, let's see what is our next topic. So our next topic is, what is data warehousing? You would have like read this term data warehousing. What is this? Data warehouse is sorted. Okay, database versus data warehouse is sorted. What is data warehousing? What is this? So basically, data warehousing is the process that you follow to fetch data from database and store it to data warehouse. Okay, this is the process. Data warehousing is the process, and this is you who is just pulling the data and storing it in the data warehouse. How? We just discussed, with the help of ETL. With the help of ETL. So you are here applying ETL logics to, to pull the data and store the data to the data warehouse. So this is a data engineer. This is a data engineer. Nowadays, I know like data analysts also perform ETLing using Power BI and no low code ETL tools. So yeah, everyone is performing this thing, ETL. So that is not the thing that only data engineer perform this thing, but but data engineer. So okay, another thing. Now you would say, hey, everyone is performing ETL. So what is the importance of data engineer nowadays? Importance is this one, data warehousing, bro, data warehousing. Applying ETL is very easy, pulling the data and storing the data. But how to store the data is the thing, bro, is the thing. That's why I have created this video, data warehousing. Because nowadays we have so many tools in which we do not need to even write the code. We can simply use UI, drag and drop, and we can simply perform ETL. But ETL is not the only thing we perform in data engineering. The major thing we perform is data warehousing. Now you would have understood, oh yeah bro, we need to master this. It's not just about tools, it's about the architecture, it's about the fundamentals, bro. Okay, because this thing cannot be automated. No, This will only, like, tools can only help you to just speed up the process, but this cannot be automated. Why? Because every data warehouse logic is unique. It totally depends upon the business. So that is why once you grasp all the concepts, then you can just build any data warehouse. Okay, again, AI proof future, right? Just learn data warehousing. Learn data warehousing. Okay, very good. Don't worry, I will just tell you how you can just master data warehousing. It's very simple. So this was all about data warehousing. Data warehousing is a process. Now I want to start. Now you would say, hey Anshlamba, do we have any practical video for this? Yes. Not in this, in the next topic. And that topic is the, you can say, the first and foremost thing that we use even before designing data warehouse. We need to do that. And if you have already predicted that, it's good. And I'm talking about incremental loading. Let me just tell you what's that. So let's talk about ETL, and then obviously we will be talking about incremental loading, because first you need to understand the whole process of ETL. Let's talk about it. And the same way you master data warehousing, you're gonna master ETL in detail, because trust me, this information is really, really, really rare, because you will get to know. Let me just tell you. Okay. So first of all, what is ETL? ETL is basically a kind of process that contains three stages: extract, transform, load. Okay, basically a process in which we perform three activities: we extract, we transform, and we load. We just do these three things. Okay, okay, this was very high level overview. Let me just tell you right from the scratch. So as we know that this is our source. Okay, this is our source and this is our database. We know that, and this database is receiving data from the APIs, from the websites, from anywhere. Okay, we do not worry, we do not need to worry. Okay, then what is this staging, what is this core? So basically just note it down. So as you know, like, this is our data warehouse. Okay, forget about these areas. Do not worry, just focus on the things that I am highlighting right now. Just database and data warehouse, that's it. Okay, just focus on these two things. So now we know that we pull the data from database and we store it in data warehouse. Okay, we do not do it directly. So what we do, we first of all pull the data from database. Okay, this is our step number one. Just write it down, everything. Okay, this is our first step. We will pull the data from the database. Okay, then we will go inside this data warehouse network. Okay, then we have two layers we have two layers within data warehouse. It is called staging and core. Staging and core. Very good. Just note it down. Very good. So now what this staging layer will do? So now staging layer will get the data in the raw form. Let me just write it for you. In the raw form. Why? I just told you. Why? Because we do not need to put load on this particular little database, because it is already just storing data in the continuous manner, right? So we just need to read the data in the as is form, or you can say in the as it is form, or in the raw form, without any transformation. We just need to pull the data and dump it in this particular layer called staging layer. Very good. So this staging layer will be storing data in the raw form. Okay, then we will be applying transformations. Let's say we are just adding column, we are removing columns, we are transforming columns, we are performing aggregations, everything, bro. Let me just write T. Okay, T for transformation. Okay, T for transformation. Okay, so we apply transformation, and finally we stored this data. We Let me just create an arrow. So we just apply transformations, and we finally stored our data in the core layer. In the core layer is your layer which is exposed to all the data analysts, data scientists, business analysts, BI developers, everyone. So they access this core layer, not this staging layer. Why? Because obviously they need to use the curated data. Curated. So this data will be in the form of curated. Like it is the curated data, or let's say transform data. So this is your curated data. Okay, so this data can be exposed and can be used to build visualizations, reports, dashboards, can be used by a data scientist to build ML models, everything. This is your layer of data warehouse that you uses right now if you are already working as a data analyst and if you are already querying data warehouses. This is the layer, core layer. Okay, okay, very good, very good. Now Anshlama, what are these two things if this is being exposed to the whole world of the organization? So this is called data marts. Data marts. Okay, what is a data mart? New term. Data mart is not a new term. Data mart is not a different term. Data mart is just a subset of data warehouse. What do I mean? Let's say this data warehouse is holding the data of whole organization, okay. So this data mart can hold your data just for the finance domain. Let's say this is just for the finance. Let's say this data mart is holding data just for the HR domain. So when we just separate the data based on the business requirement, just for the particular business use case, it becomes data mart. So data mart is nothing but just the subset of your data warehouse. So what we have done, we have used core layer. This is the core layer. Then we use this core layer and we applied some filters and we just fetch the data for the finance domain. That's it. Make sense? Because obviously when your organization has like lots of domains, this doesn't make any sense to give access to the whole data warehouse, right? No, they just need to access this finance data. That's it. This is your data mart. When we are just applying a subset, or let's say we are creating a subset of your whole data warehouse, it becomes data mart. These are just the fancy terms. You just need to understand the concept. That's it. If someone is using, hey, do you know data mart? Now you know. Okay, do not worry, I'm here to just make things simple. Do not worry. So this is your ETL. Now I hope now you know everything in ETL as well. So now what's the next thing? Now we have next thing called incremental loading. Let me just explain you what is that, because this is really important. And just a good news, after looking at the, let's say, concepts right now in this slide, we will be actually performing incremental loading practically, and you will be performing incremental loading practically. So congratulations, but do not feel much happy, because you first need to grasp the concepts, then only you will be able to perform those things. Okay, so because incremental loading is really important, really important. You cannot build any solution without incremental loading. So the thing is, this is your database. Okay, so let's say this database has data such as, let me just quickly create a table of, let's say, 4 columns. Okay, perfect. Okay, so this column is your ID, this is name, this is salary, don't mind my handwriting, and this is date. Perfect. Okay, so ID 1, 2, 3, 4. Perfect. Name is AA, BB, CC, DD. You can just put your friends or best friend's name here. Salary 10121314. So these are basically in thousands. Okay, and in dollars. Now feel happy. Okay, so now date. This is important. So let's say for date I am using date as 2000 0101. Okay. For the next record is 2000 0101 and 2000 0101, and the fourth record is 2000 0101 let's say. So this is my data in the source right now. Okay, so now what I will do, or let's say one more date here. Oh man, now you already know, right? I'm just recreating this column, because you can just click on the back button and then you will simply see the data. Okay, so now let me just recreate the date column. Okay, so 2000 0101 2000 0101, let's say, then 2000 0202 or 01 2000 0301. By the way, date is in the form of year, month and date. Okay, then 2000 03 110. Okay, then 2000 0401. Okay, perfect. So now this is my data. This is my data sitting in this in my source. Okay, this is the initial data. Like, this is the very first thing that we need to do, because we do not have any data warehouse right now. Okay, so you need to build data warehouse. How you will be building, I will just telling. I'm just telling you. So this is my data. Okay, these are like all my columns. You can just imagine. Okay, so now what I will do? What I will do? I will simply obviously take this data to the staging layer, and I will just make a duplicate copy of this data, and I will just dump it without any transformation. Then I will apply some transformations. Okay, some transformations. Let's say I added some column and I just aggregated some data, and this is my transform data now. Okay, then I will push this data to my core layer. Very good, very good, very good, very good. Okay, this is fine. Anshama, what is different now? Now the different thing comes. So this is your initial load. This is your initial load where you just pulled all the data. Where you pulled all the data. Okay, so now next day. This was day one. Okay, this was day one, or let's say day one with the history of the records. Like, so far we have these records. Day two. Now on day two, we have this data. Let me just create here. Okay, so we have next day we have two more records. Okay, and we have data with date let's say 2000 06 01 2000 06 03, and one more. Okay, one more, 2000 07 01. Okay, these are the three records that are added next day. Now just tell me, when you will be just loading this data to the staging, what you are doing, because you cannot do it. Why? Let me just tell you. So now when you will be just loading the data to the staging layer, you will be again loading the whole data. See, this is the data. So now just tell me, Mr. or Miss or Mrs. Future Data Engineer, will you like to process this data again? Tell me, because this data is already here, bro. See, this is here. You already processed it on day one. Now, would you like to process this data again? Would you? Obviously no, right? So here comes the concept of incremental loading. So what you will do, you will only load the new records. You will only load the new records. Okay, but how you can do that? How? So we use a column, or let's say a term called CDC. Called CDC. CDC means change data capture. Change data capture. Okay, so what it will do, when we perform initial load, we will we will store the maximum date, this one, to a location, and next time, next day, we will not be just using select asterisk from table. No, we will be using select asterisk from table where date column is greater than this date, so that you will only be reading these new records instead of all the records. Instead of all the records, you will only be reading the new records. This is the concept of incremental loading. So next day, you will only be loading new data. Okay, then new data will be transformed and new data will be inserted. Simple, simple, right? Simple. Okay. One thing which is very important. What's that? So let me just remove everything. So this staging layer, we every time truncate this layer. Why? So if you have understood the concept, we need to load data to this layer every day. And if we are loading data on day 2, and if we do not truncate this layer, truncate means just removing everything. If we do not truncate this layer, so what do you think? Will it process only the new records? No. Otherwise, it will again process the older records as well. So that is why every time we just truncate the staging layer. That is the recommended solution as well. We should always truncate the staging layer so that we can only pull the incremental data. Okay, but you need to have the complete knowledge. So this is not the scenario in all the cases. Okay, so this is the scenario, this can be the scenario in, let's say, 90% of the cases, but for 10% of the cases where we have to keep the history of the records, then we have to just we need to just ignore truncating this layer. Okay, so that is why in the staging layer we have two different kinds of layer. It is called, bro, I'm just explaining everything in so much of detail right now, just for you, so staging layer has like two layers within this. One is called transient and second one is persistence. Okay, one is transient and second is persistence. So this is the layer which is called transient. This is the layer which says, hey, just truncate the data, and this is the layer persistence which says, hey, just keep the data. So in most of the times we will be using transient layers. Okay, but in few use cases we use persistence as well. Make sense? Very good, very good. So now it's time to actually perform the incremental loading in real time, and then only you will be able to understand like what exactly we are doing. So what I will be doing right now, I was thinking to use MySQL Workbench or PostgreSQL Workbench to actually show you everything, but bro, world is actively moving towards, let's say, big data technologies. So I wanted to just make you understand how we can just work with modern SQL tools and technologies. And the best tool that I found is, and you will be very happy after looking at this. So this tool is Spark SQL. Bro, we do not know Spark. Don't worry. We are not using Spark. We are just using SparkSQL, which allows you to just perform all your SQL workloads as it is that you perform in MySQL or PostgreSQL or MS SQL Server. So do not worry. You do not need to have Spark knowledge. Nothing. We are just using as a platform. And the best thing is you will be familiar with that particular concept called Spark SQL. And just imagine when you will be putting Spark SQL in your resume, they will feel, okay, this person is like knowledgeable and can work with Spark SQL as well and already know much about big data. I have just chosen this technology just for you. Okay, and do not worry. You do not need to have any knowledge, bro. Do not need to worry. Spark SQL is just SQL. That's it. That's it. Whenever you are writing the code, obviously behind the scenes it is just doing all the things necessary for your big data, that is, let's say, query optimization, logical planning, creating physical planning. But you do not need to worry. You are not writing that code. You are not writing or you are not managing all those things. You just need to write the SQL code. That's it. Okay. So now let's actually get started. So now, Ansh Lamba, how we will be using Spark SQL. So for this, again, I have just chosen a like great technology, or let's say tool. It's called Databricks, and you know Databricks is very much in demand. So I want you to just put this thing in your resume, and don't worry, I will just help you like how you can just create your free Databricks account. It will just take 2 minutes, and then you will be just performing all these basic stuff on Databricks using Spark SQL. Amazing combination. Let's actually do it. Let's actually grab the skills. Okay, let's get started. In order to create your free Databricks account, the procedure is very simple, and all thanks to Databricks who have created like this particular lovely workspace that we can use it for free. So simply go to Google and simply type Databricks free account, I guess, or let's say community edition, Databricks community edition. Just write community edition. Yep. Then you simply need to click on the first link, which is login, and you can also click on this sign up for Databricks community edition. I would recommend to click on this, because if you do not have any account, you would need to click on this. So this whole web page, simply click on try Databricks. Now this step is very important, because you do not need to click on this. Okay, neither on this. You simply scroll down and simply look for this, looking for Database community Database community edition. Simply click here. Okay, because this account is also good. This account is also good. You get, I think, $40 to just spend, and then you can just perform all the things. But I would simply say pick community edition, because that is all that is required, and we do not need to just use all the things within Databricks. This is a data warehousing masterclass, so we just need to keep things simple. I do not want you to feel confused. So simply click here. Okay, then it will just ask you to enter the email. So if you do not have any account so far, just click on this button, and it will just ask you to provide the email, and then you can just provide your email, and it will just send you an OTP, and after doing all these things, it will just land you to. So now if you have already reached on the community edition page, it's good, but sometime it will not take you to that page. So you can simply come again on the Google and simply search the same thing, and now this time you need to pick the login link. So when you just click on it, you just need to put that email, and then you are good to land on the Databricks web page, Databricks homepage. Okay, so this is your Databricks homepage. Do not need to worry, do not need to worry, do not need to worry at all. We are not using Databricks. We are not just learning Databricks. This is just a data warehouse masterclass, data warehousing ultimate guide. So this is a platform that we will be using to run our SQL queries without need to just install those on-prem SQL workbenches. And obviously, when you will be actually building those SQL scripts, you will feel that you are using Databricks, because obviously you're using Databricks, and you will be familiar with Spark SQL, which is nothing but just SQL. Okay, so do not worry. Let me just tell you some basic stuff. So simply need to just go on this workspace. Do not worry about all the things now, because you just focus on data warehousing first. Okay, just click on this workspace. Then just click on workspace for one more time. Then you will be landing on this page where you can actually create workspace. So workspace is nothing but a kind of, you can say, a folder in which we just store our notebooks. Okay, simply click on this create, and I will simply pick a folder. I will create a new folder, and I will simply say data warehouse. Okay, simply click on create. So it will just create the data warehouse workspace for you. See, now you can just create your notebooks within this. So simply click on create, and simply click on notebook. Simple. So this is your notebook. This is your notebook. And if you are already familiar with Jupyter notebook, this is almost similar to that one. Okay, all the functionalities are here, so you do not need to feel lost when you are just landing on this notebook. And now you will be saying, hey, how we can just perform SQL operations? Hold on, baby, hold on. Let me just tell you everything. So first of all, just rename this notebook. Why? Because it will be handy when you will be just saving this notebook and for the future use cases. So I will simply say notebook 1, because I might be creating multiple notebooks. So this is just notebook 1, and do not worry, I will just upload this notebook on my GitHub repository as well. Notebook 1, notebook 1. Perfect. So now In order to just start doing anything in Databricks, you need some compute, right? When you just write SQL queries on your machine, your compute is your laptop, your computer. But this is Databricks. Where is the compute? Where is the compute? We will be creating a compute. Compute means some resources that can actually run your SQL queries, right? So simply click on this connect button, and then you will just need to say create, attach, and run. What is this? This is basically a cluster, Spark cluster. So this is a compute that we use to process our data, and it will just take, I think, 2 to 3 minutes. And once you see the green light, that means it is live, and it will be terminated automatically after inactivity of 20 minutes, I guess. And how you can just create one again next time, simply click on this drop down and create new resource. That's it. It is free. It is free, and that is why I thanked Databricks to provide us this free resource so that we can actually start with the SQL and anything Spark related to Spark. Okay, so I will show you something special. So this is called Python, obviously. So primarily we use Python codes in Databricks, okay, and that is why you would have heard PySpark is very popular. So that is not the only thing we can do in notebooks. Simply click on this, and then you will see multiple languages option. Wow. So that means we can also use SQL. Oh, simply click on this, then your default cell will be converted into SQL cell. See, you can see percentage SQL. So you have two options to convert your cell into SQL. Either click on this, or you can simply write percentage SQL. And there's one more thing. I think we can also change the default settings here in the edit. And I think it was in view. I don't think so. It should be in view or file. Yeah, change default cell language. When you just click on it, you can just pick SQL instead of Python, so that every time you do not need to convert your Python code into SQL. And obviously we are using SQL, so I would recommend you to do that. Simply click on don't show again and confirm. So now every time you will be running a cell and going to a new cell, it will be a SQL cell, not a Python cell. Okay, very good. So now we can also do some good things in Databricks. Databricks, obviously we can do a lot of good things, but just for the sake of the knowledge, you should know that. Let's say I want to insert one cell. I will simply click on plus code. Okay. So if I want to use a heading to just make my notebook readable, how I can just do that? So I just need to use a command called percentage MD, or I can simply pick here markdown. It will automatically fill this percentage MD. So now whatever I will be writing in this cell, it will be treated as a heading. So I can simply use hashtag, and I will simply say incremental loading, incremental data loading, incremental data loading. Let me just run it. So how we can run it? Same way you run your Jupyter notebooks, shift plus enter, done. Shift plus enter, just press shift plus enter together, that's it. So now, as you can see, it has just created a heading for me. That is the best thing of notebooks, right? So it is like turning on right now. It will just take, I think, 1 to 2 minutes. So if you just run this cell, I know this is a blank cell, but still, if you just run this by hitting shift plus enter, you will land on the second cell, and this will be automatically a SQL cell. Perfect. Now our environment is set up. Our environment is set up. Okay, very good. Now, as you can see, it is showing waiting. Why? Because our cluster is not ready. So once this cluster is ready, it will automatically run this cell. Okay, very good. So see, now you are just familiar with Databricks as well, and you are like afraid, hey, we do not know how to use Databricks, blah blah blah. It's not like that. If you do not know how to use it, just install and get started with it, bro. That's how you learn, right? That's how you learn. First of all, just tell me, are you excited to perform your first incremental loading pipeline? Or let's say first incremental loading. Even if you have performed incremental loading in the past, it will be a good learning for you, right? So are you excited? This is the best thing I would ask. Are you excited? Because we will be just performing all the things we have learned so far. That is why I have designed this video in such a way so that you will be feeling like everything in real. It is not just like covering the theory, that's it, blah 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 blah, incremental loading is no, 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 no. You should know like what is that. You should know like how to incrementally load the data. You should know how to establish the staging layers. You should know like how we need to do things, right? Yeah, right. Okay, so I think it should be ready in just 2 minutes, and let's get started. So as you can see, our cluster is online. No, it's like live. It is showing the green sign. So now we can just perform anything we want to perform in this notebook. We can just process our code, we can just write our code, we can run our code, because now cluster is active and we can just perform anything with this cluster. Okay, makes sense? Very good. So I will just show you something. Whenever you use Spark SQL Workbench, no, just SQL Workbench, or let's say MySQL Workbench, PostgreSQL Workbench, you see all the tables, all the bases on the left hand side, right? It is exactly the same, exactly the same. You just need to click on this button. It is called catalog. It is called catalog. Okay, let me just click on this. Then you will see something called as Hive Metastore and samples. Okay, so you just need to, by the way, this is the catalog. It is called Hive Metastore. You do not need to worry about what is Metastore, then what is catalog. So just telling you the hierarchy. First of all, we have something called as catalog. Okay, and then we have, let's say, databases. Okay, then we have tables, and on top of it we have Metastore. Okay, so this is the hierarchy. Don't need to worry, it is just out of the context, but not out of data engineering. So just giving you some hints so that you can just feel aligned. Okay, just click on this drop down. You will see something called as default. Obviously, whenever you use any SQL workbench, you just see the DBO, or let's say default database. In this we have default. Okay, so we have nothing inside this because we have not created any table. Now we will be just creating two databases. One will be our database, second will be our data warehouse. And now you know, what I'm just telling. Okay, makes sense? Makes sense? Okay, perfect. So now what we need to do, we need to create a database first of all, because obviously we are just preparing our source. Okay, we are just preparing our source, so we need to just create databases. How we can just create? Exactly same, bro. I told you just use the same SQL syntax, same SQL statement. What is the syntax for creating database? It is create database name. Exactly same. In our scenario, what is the database name? We are using a database called sales. Okay, because I want you to learn everything we have discussed so far. So we will be just creating a database and we will be just pulling the data from it incrementally. So create database name is sales. Very good. Then just run this. Simple. Perfect. Has it created the database? Yes. You can simply verify it. Simply click on refresh. See, sales. Now within this, I will create a table. So to insert the data, you can just use simply this code. Okay, and again we just need to write sales.orders. I forgot to use it, so don't worry, I will just give you the code for this as well. Simply run this. Simply run this, and it's done almost. Yeah, it's done. So we have 10 records for our source. Okay, then simply run this for one more time, and now this time you will see the result. Perfect. We have order ID, order date, customer ID, customer name, customer email, product ID, product name, product category, region ID, region name, country, quantity, unit price, total amount. This is the source. And why I have just picked, let me just click on this data catalog for one more time so that I have like more space, because you already know like we have tables here. Okay, so why I have picked this particular data? Why? So that you can feel aligned with the data, because in the real world as well, when you're just working in a company, it is very possible that you will be dealing with order IDs, order date, then customer ID, customer name, customer email, then product ID, product name, then product category, then region ID, region name, and country, then obviously quantity, unit price, total amount. So this is a kind of real time data that I have picked so that you can actually feel that what you are doing. And if you just observe the data carefully, we have data on a daily basis. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. And as per our concepts, what we will be doing, we will first load this data. We will first load this data to the staging layer, and then we will just apply some transformations, like can be anything. Then we will just load this data to the core layer, to the core layer. Let's do it. Let's do it. And before that, we simply need to create a data warehouse. And how we can simply create it, I will simply say, let me just create a markdown so that we can just have a separator. Okay, so markdown, and I will simply say data warehousing, because from here we are just performing our data warehousing. So I will simply say create database, and this time I will simply say sales data warehouse. Sales data warehouse. Okay, this is my database. Obviously concept is same, like database is the object that you create, but it differs how you store the data. Okay, so database, sales data warehouse, let's create it, let's run this. Okay, perfect. So now within this, we need to create a layer. Which layer? Staging layer. Very good. So now in the staging layer, what we will be doing, we will simply say create table, and I will create a table under sales data warehouse, obviously. Then what I will do, first of all, let me just say which kind of table it is. It is called staging. Staging is for, like, STG is for staging. Staging underscore sales. Okay, this is my table. But what will be the definition? What will be the definition? Tell me, what will be the definition? So the definition will be, this is very important. Just focus. Definition will be as select asterisk from sales dot orders. Make sense? Make sense? So you are just creating a table, okay, and applying as on top of it. This is your initial load. Initial load. Okay, let me just write, it is initial load. Initial load. Very good. Let me just run this. So this is your initial load, where you just need to pull all the data. All the data. You do not need to worry about, hey, I have this data, I have that data. You just need to load all the data, all the 10 records, all the 10 records. Okay, very good. Very good. Now let's say you want to apply some transformations on top of it. Let's say, okay, let's say you want to just apply some transformation. So what we will do, this is our let me just add one more markdown here, because this is our staging layer. So I will simply say text, this is my markdown. So I will simply say with 3 hashtags. More hashtags you use, so the smaller heading will be. So I will simply say staging. Perfect. Now I will simply go here, and I will simply create another text, and I will simply say transformation. Perfect. Staging, transformation. So what is the transformation? Transformation is, let's say, first of all, let me just show you the data how it looks like in staging. So for that, we can simply say select asterisk, select asterisk from sales data warehouse dot staging sales. Let's see how data looks like. Okay, this is your data. Obviously, as per the definition, as per the rule, data should be exactly matching with the source, and data is exactly matching with the source, as you can see. Perfect. Now the transformation is, what is the transformation? Now the transformation is, I want to, yes. So okay, let's do it. So in the quantity, I want to transform this. So the transformation is, I want to multiply this quantity by 10. I want to multiply this quantity by 10. This is a requirement. We need to refine our data. So maybe in the database it was stored as 2, but I know that this is 20. Okay, this is a transformation that we need to apply on our data. It can be any transformation, bro, any transformation. This is a kind of an example of transformation that we are performing. So what we will do, we will simply say, hey, just so what we will do, we will simply say we need to apply 2 into 10, or let's say quantity into 10. So we are just applying some transformation. Make sense? Make sense? Or if you just want to go with the real time scenario, or let's say you want to remove some nulls. Obviously we do not have any nulls, but a real time transformation can be when you're just removing the nulls. When you are removing the nulls, let's say we want to make sure that we are not storing the data in which we have quantity equals to null, because sometimes due to any error, due to corrupted data, we can just have nulls, right? We can have nulls in quantity column, and it doesn't make any sense if we have 0 in quantity, or let's say null in quantity, and we are just storing that information. So we need to make sure that we are applying this transformation before actually storing the data into the core layer. Let's apply this transformation. Let's say, so I will simply say select asterisk from staging sales data warehouse, okay, where quantity is not null. This is my transformation. Let me just run this. Obviously we do not have nulls, but what if like in future we will be having nulls, right? So obviously for now we have 10 records. Very good. Now I will create a transformation. Like now I have like two choices. I can create a separate transformation layer as well, or I can directly send the data to the core layer. Did you get it? Okay. So this is the transformation that we have applied. Okay. So now what we'll be doing, there are two ways. Either just copying this transformation and storing the data into your data warehouse core layer, or the ideal thing is you should create a table. Let's say create table, or let's say create view, which will be called as sales data warehouse dot transform, and it will be sales. Make sense? So here we have staging sales, here we have trans sales. Perfect. So I will simply say as. So this time we have not created a table, but we have created a view. That means we are not storing this data. No, we are not storing this data. We are just storing the query, because next time when I will be creating a core layer, okay, let me just run this. This is my core layer, this is my staging layer. Let me just add layer here. Layer, perfect. Staging layer, transformation, this is core layer. So core layer will be very simple, because we do not need to worry about this query, because this query is saved in this particular view. That is the recommended approach. Obviously the more you understand, more enhancements you can do, right? So I will simply say create table, and then I will simply say sales data warehouse dot core sales. This is my data warehouse core layer, and I'll simply say select asterisk from this particular view. Instead of copying the query, I can simply use view that set. Simple. So simply run this, and this should create my core layer. Perfect. Now I'm really excited to see my data. So let me just create another markdown, and I will simply say data warehouse core layer display. Okay, let's display the data and let's see what we have in our core layer, because this core layer will be exposed to all the data analysts. Okay, select asterisk from sales data warehouse dot core sales. Perfect. Let me just run this. Perfect. Very good. So this is our core layer of our data warehouse. Okay, make sense, make sense, make sense, make sense, make sense. Okay, perfect, perfect, perfect. Don't worry, don't worry, don't worry. We are just discussing incremental loading. This is not your, let's say, data warehouse. It's not your final data warehouse that will be actually exposed. Okay, this is not your actual data warehouse that will be exposed. No, no. Actual data warehouse is exposed in the form of facts and dimension. And don't worry, I will just tell you that as well. Don't need to worry at all. Okay, perfect, perfect, perfect. So what we can do, what we can do, what we can do, because I want you to feel aligned. So now you know like how data is being served. Okay, now you know how data is being served. So now here in the transformation, we have just saved the query in the form of view. See this view. Very good. And this core layer is not your final layer. Final layer will be in the form of, let's say, facts and dimensions. But for now, we are just using the transformed data in the form of your like core layer, because we have not studied the data modeling right now. Okay, so this is your core layer for now. Okay, very good. So now let's say next day, or let's say after 5 days, or let's say next day we got 5 more records. We got 5 more records. So how we will be handling that? How will we handling that? So now you will say, Ansh Lamba, we will just insert 5 more records here, and then when we will be just looking at the sales.orders, which is our source database, it will be having 15 records at in that particular scenario. You are absolutely right. But Ansh Lamba, you are using this statement for staging, select asterisk. So again, it will just read 15 records, because 5 plus 10. No, because I told you in the concept, for the incremental run, what we use CDC. So here we will be using change data capture, and we will be only reading the changed records. Okay, so let me quickly insert the new data, 5 records, and let me show you how we can do that. Let me just show you. So let's quickly insert the new data, and this is our data creation. So this is our first load. Let me just write it for, or it's fine. We can simply insert new cell here after this code and simply say insert into this. So now it will just insert the new records. Okay, very good. Let me just run this, and perfect. It has inserted records. Yeah, it is saying waiting. Yeah, now it's done. Okay, perfect. Let me just query this table for one more time, which is our source. Now you will see we have 5 more new records. Okay, 5 more records. Why it is not showing? Oh man, I forgot to add sales. Let me just add sales dot, so that it inserts the data in our particular table, not the default one. Okay, now let me just rerun it. Perfect. Now as you can see that we have 15 rows. Perfect. Now we have 15 rows, and now what you want to achieve, you want to just read the 5 records instead of 10 records. So in order to achieve this, as we know that in this staging layer, we just need to read the new records. So how we can just do that? We will simply use a command called create or replace table. Why? Because as I just mentioned that we need to truncate this table every time. Every time means every time. So we are truncating the table every time we have the new records, and we are using a predicate in our query which says where, or let me just go to the next line, where order date greater than 2024 0 to 10. Why? Because this was the maximum date before our new record. So these are our new records, and this is our maximum date. So we want to read all the records after this particular date. That means incremental loading, and we are truncating the table using create or replace table command. Got it? Very good. So what we can do, we can simply run it, and perfect. Yes, we have like recreated our table. So now same thing we need to create here as well, create view and this thing like blah blah blah. And by the way, this is not a big deal because we are just using a query on top of our staging sales. So that means whatever data they have, it will just show that only. So this layer is good because this is just creating a view on top of the data that we have. Now let me just show you still, so that you just feel confident that in the transformation layer we will be just having, let's say, 5 records. That's it. Let me just show you. Let me just write a code and let me just see, select asterisk from sales data warehouse dot trans sales. So let me just show you, and it will just be having 5 records, the new ones. That's it. See, 11, 12, 13, 14, 15, and that's it. That's it. Now this data, let me just delete this. This data will be going here. See, this data will be going here in the core layer. This data. Okay, make sense, make sense. By the way, that's why I told you that this is not the final layer that we create, that we use. Why? Because the thing is, if we just use create table, or let's say create or replace table, or whatever we need to just do, we cannot actually do this because it will just remove the 10 more records. But this is how incremental load works. Okay, so what we do in case of core layer, we just create the table, let's say the same way did here, using the structure like this. So we just need to copy it for the core layer, and we can simply paste it here, and we can simply say create or replace table because we already have a table. So that's why. So we need to just create table like this, and we simply need to say data warehouse and then core sales. Okay, let me just run this. Okay, so it is like removed, like it is a new table. So now every time what we'll be doing here, we will be running here in the core layer. Let me just insert this code. We will simply say insert into. So let's say, let me just delete it. Let me just add cell after this. So I'll simply say insert into every time, insert into sales data warehouse dot core sales. Perfect, simple. And when I will be just doing it, I will simply say select asterisk from this trans thing, like what was the schema name, sales data warehouse dot trans sales. Perfect. So when I'll be running it, my core layer is ready. This is the fundamental of incremental data loading. But actually we do not serve our data as it is, because we create data models. Now it's time to actually look at the data modeling part, where you will be learning about facts, dimensions, and so much of these things. Now it's time to see, because now you know the concepts of incremental loading. Now let's see how we can just perform data modeling. Let's see. So now finally it's time to talk about data modeling. So now, so far you know like how to reach to a point where you are incrementally loading the data, but now you cannot serve this data to your stakeholders. Why? Because you have data in the form of one big table in which you have like so many columns. Obviously in our particular scenario we also have like so many columns. So when we need to just build reports on top of this kind of data, it is not efficient. Plus, if your business managers, or let's say if your business wants to take data driven decisions, it is not easy to understand and just analyze that data which is in the form of one big table. And second thing is, not second, I think third thing, yeah, third thing is, when you are actually building the reports, like the real reports, that dashboards, those are not easy to maintain when you have like everything in like one table, like everything. How you will just track back the changes, how you will just do all those things, you can just imagine like how difficult it will be. In this scenario we just have like, I think, 10 to 15 columns. What if we have like 200 columns? 200 columns, can we imagine 200 columns in a table? Yes bro, 200 columns is nothing. That is the big data. So when you are just working with big data, when you know like the size of data is too big in the form of rows, but in the form of columns as well, then you have to use something called as data modeling. Now you will say, hey, why like, what if like we do not use data modeling in data warehouse? Like, what if like directly build data warehouse without data modeling? So the thing is, in order to efficiently store the data without any redundancy, in order to save storage cost, we have to build data model. Make sense? Make sense? So data modeling, let me just write it for you. So data modeling is nothing but just a process to structure your data, to structure your data, to give it a structure, bro, to give it a structure. So this was the overview of data modeling. And let me just tell you like what exactly is a data model and what are the types of data models. Yes, we have like multiple types of data models. So let me just tell you. So now let's talk about types of data models. Okay, let me just tell you. So let's say you are working in an organization, okay, and you have like 100 columns in a table. Okay, perfect. So now the the center of the topic to actually build the data model starts with a concept. Starts with a concept. That is why it is called conceptual data model. So what this type of data model will be having? Okay, so this type of data model will be having, let me just write it for you, and I hope you're taking notes. So this type of data model will be holding, let's say, business needs or high level business requirements, or let's say business needs, high level business needs, what they need in the data model. Let's say they will say, hey, we have one customer table, and then they will say, hey, we have one sales table, hey, then we have one products table. That's it. They just have like high level understanding. That's it. Now this is the most important one, logical data model. Logical data model. What is a logical data model? Logical data model goes one step beyond the high level understanding. It will say, hey bro, we understood that you have customers, product, sales, but how these tables will be connected to each other, what will be the joining keys, what will be the attributes. So all those relations, all those connections, all those logics are included in this logical data model. In this logical data model, understood? Understood? Where we are defining the logic. We know that we have like this table, this table, this table, this table, this table, this table, but how to connect, how to just initiate the link, this is the area where we just build the logic. Okay, so this is for logic such as joining keys, and even before joining keys, let's say logic such as how to connect tables. Okay, how to connect tables, and then we can say joining keys or joining attributes. So this is like one step ahead after conceptual, and this is the area where you see data models such as ER, entity relationships. So we have such as ER, we have normalization. Okay, and we have one more special thing. I will just talk about it in just next few seconds. So before that, I will just talk about physical. So what is this physical data model? Physical data model is your actual data tables which are residing on a database. These are like actual physical tables with all the constraints. Let me just write it for you, like with all the constraints, physical tables, real physical tables, where your logic is moved one step ahead and actually created the tables with all the logics. So real physical tables, and then you can say constraints such as primary key, this key, that key, constraints, etc. Okay, now let's move back to the logical one. Why? So as I mentioned that we have ER, we have normalization, but Ansh Lamba, what do we use in the world of data engineering? Because we have heard that normalization is used on the database side, that is for DBAs, that are database administrator, but data engineers do not use normalization. No, they do not use first normal form, second normal form, third normal form, fourth normal form. No, we use something called as dimensional data model. What is this dimensional data model? Let's talk about this now. So what is dimensional data modeling? Dimensional data modeling obviously is a kind of logical data model. Like after concept, when we just need to build the logic, this logic says that just basically it is a technique. Okay, so it says that just store your data in the form of facts and dimensions. Okay, facts and dimensions tables. So these are the kind of tables that we use. Okay, it says store your data in the form of facts and dimension tables. So here we will be just restructuring our all the table, like we have like one big table. Okay, we will just break that table in such a way that we will be having fact tables and dimension tables. Okay, let me just compare it with the traditional approach that DBAs follow for relation like ER diagram. You would have seen, that's why I'm saying that. So let's say you are using that one big table, you remember. Okay, so what they will do, they will just break that table, this big table, in the small tables. One table will be your orders table, then they will just apply a join with customers table, because they will just break that table, right, the like big table. Then they will just apply left join with another table called products table. So this way they will be applying join like this way, and they will apply one join here with region. So they will be using entity relationships. They will be creating entities based on the normalization rules, but data engineers do not follow normalization rules. Yes, we do not follow normalization rules. We build our logic based on facts and dimension rules. What are facts and dimension rules? Let me just tell you. Okay, so let me just take you the fact table. First of all, fact table. Let's talk about fact table. So let's say this is your big table. Let's say this is your one big table. Okay, first of all, we will create a fact table out of it. Okay, and in the fact table there are basically two rules. You know now that we will be dividing our one big table into facts and dimension tables. Okay, you know this, that we will be having multiple tables now, like small tables, to model it. Fact table is the only table which is available at the most granular level. Let me repeat. Fact table is the only table which is available at the most granular level, because we do not perform aggregations on fact table. We do not. We do not. So this is available at the most granular, or I would say the most real granularity of the data. So if we have, let's say, one record in the original table, we will be having one record. Two. If we have like 10, and you know that in our case we have like 15, so we will be having 15. We will be having 15 records. This will be the most granular data. But here's the catch. In the fact table, as the name suggests, we will just be storing facts. What are facts? Facts are your numbers. Facts are your numeric columns. Those are facts, right? Okay. So in the fact table, we will just be storing numeric columns, and we will be storing all the keys. Keys means your foreign keys that will help to connect your fact table with the small dimension tables. Okay, okay. So this is your fact table. Just remember, in one data model, I'm just talking about one data model, not like multiple ones. In one data model, we will be having one fact table and multiple dimension tables around it. Make sense? Doesn't? Let me just explain you dimension, then it will just make more sense. Okay, now let's talk about the dimension tables. So dimension tables will be first of all, opposite of fact table. Why? Because in dimension table, we cannot store any numeric value. Any numeric value. By the way, numeric value doesn't mean like 1, 2, 3, 4. Numeric value means the value that we can aggregate. Obviously, keys are also in the form of numerics, like numbers, but that doesn't mean that is a numeric column. Numeric column means that holds some value like quantity, price, cost, revenue, like all these things, right? So these things cannot go to the dimension table. Make sense? These things cannot go to dimension tables. One, and the first and the foremost rule, numeric columns cannot go to dimension tables. So what goes to the dimension tables? So it it only holds the contexts. Okay. On oops. Let me just rewrite. So it only hold the context. So it will only hold the context of the column or context of the table. Let me just make it very clear. Let me. So as you know that in our particular example, we have so many columns related to customers, customer ID, customer name, customer email. You saw it, right? Okay. So that is one context. That is one context of the data. That is from the customer's perspective. So we will create a different dimension table for customers only. That will be our dimension table 1. That will be called as dim customers. Okay. Then you would have seen multiple products, product ID, product name, product category. That is a new context. That is a different context, right? That is not relevant to customer. That is a product. That context is from product's perspective. Then we will create a new dimension called product stem. So this is our product stem. Very good. Don't worry, bro. I will just tell you how to implement these things. I'm just making sure that you are very clear with these things. This is the knowledge that you need to have. So we will simply create dim products. Okay, very good. Dim products. Now you would have seen something called as a region is a different context. So we will be creating a different dimension table here for region. Then you would have, let me just write it for you. So dim region. Okay, then you would have seen something else. Let's say date. So we'll simply create dim date. Yes. So now we have separated our data based on the context. So in dimension, we just create a dimension table based on a context. That's it. That's the simplest definition. It holds the context. Okay, it holds the context on which you want to perform aggregations. For example, you want to find the revenue by customer. This is your go-to table. You want to find revenue by region. This is your go-to table. You want to find revenue by product or product category. This is your go-to table. You want to find revenue by month. This is your go-to table. So what we are doing? We are just, let me just draw the fact table. This is my fact table in the middle. Okay. Fact table. This is my fact table, and this fact table just has numbers. But if we want to add context to those numeric values or those metrics, we need to just create dimension tables, and we just need to apply aggregations on these contexts. That's it. That is why all the contextual information will go to dimensions, all the contextual information, and only the numbers will be here. Revenue, sales, number of orders, cost, everything. And along with it, all the foreign keys. Why? Because then only you will be able to join your fact table with your dimension table. Simple, common sense. Okay, because then only you will be able to connect, bro. See, only then you will be able to connect. So this will be holding all the foreign keys. I hope it makes sense. I hope now you have understood everything fact about fact table and dimension table. Now I will show you how to implement this, and then obviously you will just dig deeper inside these, because we have multiple types of fact tables, we have multiple types of dimension tables. So I will just talk about that as well. But now I know you are really excited to actually build the solution, like how we need to create it, because we do not use the joining keys. We create something called as dimension keys. So I will just tell you how you can just create dimension keys, and I will just tell you each and everything that you need to know. I hope that now you have like clear understanding about fact tables, about dimension tables, and obviously some of the more things will be coming to your way when we will be just actually building that, when we will be actually building our dimensions and fact tables. I will tell you a lot of things, like how to decide the primary key, how to just create dimension keys, and what will be the primary key of our fact table, like everything. Okay, okay, okay. So I know you are really excited. So let's actually build this solution, and let's actually build our first data model, which is dimensional data model. And we will be building the whole data model using our one big table, so that you will feel that you have actually built everything from scratch. Okay, so you are receiving one big table. Now you will break all those columns into small tables. Let's do it. And before that, let me just tell you one more thing. What is the star schema? Because this is a very popular term, star schema, snowflake schema. So when we decide that we will be building a dimensional data model, when we know that we have like one fact table and multiple dimension tables, still we have two options to pick dimensional data model. One is star schema, second is snowflake schema. Now what is a schema? Schema is just the logical structure that we are picking inside data model. So it can be either star schema or snowflake schema. So when we just pick star schema, and star schema is the same example that we have just discussed, so that's why I thought like it should be very much relevant when I just need to discuss this instead of just discussing it after. So when we have only one fact table, okay, when we have one fact table and multiple dimension tables surrounding it, it becomes star schema. And one thing to note, there is no hierarchy, there is no hierarchy between the dimensions. That means we just have one dimension attached to the fact table directly. That is our star schema. And star schema is the schema or data model that industry uses 90% of the time, I would say 99% of the time, because the second schema, which is snowflake schema, is not easy to maintain. It's not easy when you have like so much of columns. Yes, we do have that strategy, and we do have like when we have to use it, but it's always recommended to not use it if you can just like do your work without it. So it is always recommended to always use star schema, and that is why we will also be building star schema. So do not need to worry, but still you should know everything. Okay, then what is a snowflake schema? We still need to see. Okay, let me just show you. So this is your snowflake schema. So the difference is a small difference. So the thing is, there will be one fact table, okay, and obviously multiple dimension table. But in snowflake schema, we have one additional thing. We have a hierarchy. We have a hierarchy and indirect linkage of a third dimension with the fact table. What do I mean? So as you can see, this linkage is one to one. Like I'm not telling about relationship like one to many or many to one. Linkage, this is directly connected to this one. Linkage, I'm again repeating, this is not the relationship. Linkage, this is directly attached to this one, this is directly attached to this one, this is directly attached to this one. This is fine. But if you just look at this dimension, this dimension, this dimension, So dimension 3 is directly attached to fact table, but dimension 5 is indirectly attached to fact table. Why and how? Because dimension 5 is attached to dimension 3, obviously. So when it is attached to dimension 3 indirectly, it is obviously attached to fact table. So when we have a kind of hierarchy within the table, we call it as Snowflake schema. What is the alternative of it? When we have hierarchy, one simple thing, you can simply apply join between these two tables and you can just add those columns here. Then there will be no dimension 5 and dimension 3 will be directly attached to fact table, and we can convert Snowflake schema into star schema. That is the recommended approach. But obviously there are some scenarios where we cannot and where we should not. That is why I've said like 90% of the cases will be using star schema only, but yeah, 10% we should just keep it for hypothesis. Okay, we should not say like 100% in hypothesis testing as well. Like we just keep the interval like 90 to 95%, that's it. So that is the thing between star schema and Snowflake schema, and there's nothing fancy term. The only difference is the hierarchy. That's it. Do not make it complicated. It is very simple. So now let's see how we can just build this solution. Let's see. So now, let's recreate our all the things, because we have already learned incremental data loading. So now in order to just create dimensions and fact tables, let's create a new database. It's called sales new. Yeah, simple. Let's create our new database. Okay, and then obviously we need to say sales new dot orders. Let's create this. Let's create this. Okay, perfect. So now we can just simply insert our data into this table, sales new dot orders. Let me just run this. So it is just inserting the data into this. It's done. Very good. So actually I do not need to add 5 more records because we are not performing it. So let me just delete the cell, because it will be easier for you to look at the minimum of, like, let's say at least like instead of just looking at 15 records, because otherwise I would need to just scroll it down, because I want to show you the very important step of just creating the dimension surrogate key. That is the main thing. And let me just simply say sales new dot orders. Okay, and then it will simply return obviously table. Yeah, because now I do not need to scroll it down, because I can see like 10 records simply. Okay, simple. So now let's create a new data warehouse. It's called orders data warehouse. Okay, let's create orders data warehouse, and then staging layer will be for orders data warehouse. Orders data warehouse. Yeah, simple. Oops, we need to say sales of orders data warehouse. Sales new. Perfect. Order data warehouse cannot be found. Really? Oh, we just created data warehouse with order, not orders. So let me just run this. Okay, almost there, almost there, almost there. Very good. Okay, so now we know that what transformation we will be applying. Just this one, right? So I'll simply say order data warehouse, and this should also be registered under order. That's it. We need to stop here. Exactly. So let me just click on this delete button. So now, as you know, let me just delete this as well. Now, as you know, our transformation layer is ready. Okay, now let me just delete this as well. Yes, and let me just delete this as well. Perfect. Now, as we know that our data warehouse is ready till transformation layer, but now we will be just creating dimension and fact tables in order to expose it to the other users, other data analysts, other business analysts. So in order to do that, first of all, I will just show you the data. I will simply say select asterisk from uh, order data warehouse dot trans sales. Perfect. And now I will just tell you how you need to break the data in the form of dimensions. Everything will be discussed right now. So first of all, just have a look at the data and just try to remind all those things that I just talked about. Just try to remind yourself. Just try to remind. Okay, So as you can see, this is our one big table. We have order ID. Okay, makes sense. This is our primary key of this particular table. That makes sense. This is the order date, which can be unique or which cannot be, because we can have multiple tables, but we are not worrying about this thing. Now, as I just mentioned, now just tell me one thing. Can these columns be treated as a different dimension? Can these tables be treated as a different dimension? The answer is yes. Why? Because this is a different context. This is a different context. And for every context, we create a dimension table. So these three columns can form something called as dim customers. This can be our first candidate of our dimension tables. Yes or no? Obviously, yes. So as you can see that we have customer ID, customer name, customer email. Let's say in future we have customer home address, customer's phone number, everything. So everything related to customer will be going to customer dimension table. Simple, 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 simple. Make sense? Make sense? Okay. So does that mean we will remove this column, this column, and this column from this table? The answer is yes. So Ansh Lamba, how we will be connecting this dim? Let's say, on, because you are saying this, we trust you, we create a different table for dim customers, but how we will be just connecting this fact table with this particular dim table? How? So here comes the role of dimension surrogate keys. What is a surrogate key? Surrogate key is basically the false key, the pseudo key that we create in order to apply joins. Just tell me one thing. Customer ID is starting from like 101, 102, 103. That makes sense because that is giving you the context related to customer that has a meaning, which is also known as business key. But surrogate key doesn't have anything. It is just a key. It is just a key. Okay. Second question. Okay. Just ask. Second question is, if you just closely observe the data, we have 101 here, we have 101 here again, we have 102 here, we have 102 here again. Ansh Lamba, we have duplicates in the table. How we will be able to create a joining key? Very good question. Very, very, very good question. So in this particular scenario, we just pick the distinct records. That's why I used a term when I was explaining you the concepts, that only the fact table only the fact table will be having the most granular level of the data. Other dimension tables will not have that granularity, because now if we are creating customers dimension table, we will not be storing this record two times. We will just be storing this table one time. That is why another question that can be asked in your interviews, that is why whenever we apply join, or let's say we build relationship between your fact table and dimension table, it is always many to one. Many records are in fact table and only one corresponding record is there in the dimension table. Make sense? Make sense? Yes or no? I hope so. I hope so. So now this is your first dimension table. First dimension table. I hope that it is making sense right now. So Ansh Lamba, one quick more question before implementing this. Yeah. What should we create first? Dimension table or fact table? We should always create dimension table first, because only then we can grab the dimension surrogate keys. Obviously, bro, first you just create all the dimension tables. Okay, let me just show you here. Let's say you have the fact table. Okay, these are the numeric values, make sense, and these are the columns for keys. So this is your dimension 1, dimension 1, dimension 2, dimension 3, dimension 4. Okay. So in order to fill these columns, this one, this one, this one, this one, you need to fill the dimension keys, surrogate keys, joining keys. When you will be able to do that? When these tables are completed. Okay. So now without wasting any time, we will be just creating our first dimension table, and similarly we will create all the other dimension tables as well. But first table is very, very special because this table will be clearing your all the doubts, all the doubts, all the doubts. And then at the end, the next second, like you can say, the second most important thing will be the fact table creation, because that is, I do not want to just give you the spoiler, so let me just show you. So first of all, let's create our dimension customers table. Okay, let me just write one text which will be, let's say, I will simply say customer dim customers. Let's create this. So in order to create dim customers, I will simply say, so now you know what is our source. That is simple. Our source is this one, right? This is our source. Makes sense, right? Okay, this is our source. Order data warehouse dot trans sales. Okay, let me just copy it. Okay, let me just apply it distinct command over this. Select uh, distinct. Now you will tell me what should I pick, what should be my candidate, because I just mentioned distinct of what, which column I should pick, which column I should pick. I have like three let's say these three columns. Okay, so I'm just telling you for one more time, because for the other dimensions I will not tell you. You will just tell me like what will be the what should be the column that should be the ideal columns in those dimension tables. So for in this particular dimension we have just three columns: customer ID, customer name, and customer email. Make sense? Very good. Now let's create this distinct customer ID, and I can simply create an alias for it, and I will simply say customer ID. Perfect. Then we have something called as not distinct, because one distinct is fine. So next we have customer name. Okay. Then we have customer email, I think. Customer email. Yeah, customer email. So this is our table. This is our table. Is this fine? Is this fine? Like, should we just create this table like this? What do you say? Should we just create table like this? Not really. So let me just run this first so that you would know like what I'm talking about. So oops, from that particular table. So let me just run this. You will see only the only 7 records. Why? Because we have removed the redundant records. So now you will see we have customer ID, we have customer name, we have customer email. Okay. So what will be the joining key? Joining key can be your customer ID. Okay. And customer name, no, I don't believe so, because customer name can be same for different users, and customer email can also be the candidate of joining key, but I will simply keep customer ID as my joining key. Okay. So whenever I will be seeing this customer ID here, I will simply grab the key for it. But where is key? Where is key? And how to generate that key? Basically, we create surrogate key using two things. One is row number. If you do not know about row number is a window function that we use to generate let's say unique number for every single row. So one method is row number. Second method is monotonically increasing ID, which is available in PySpark. Okay, but we are just using SQL, so I will just tell you like how to create surrogate key using row number. Okay, so row number, what will do? It will do the same thing that you are seeing here, like 1 2 3 4 5 6 7. Obviously this is not a column, but I'm just telling you. It will simply create a column and it will say 1 2 3 4 5 6. Simple. And how to create that? It is very simple. You just need to use row number like this, and then over, and then you need to decide order by. Okay, and order by should be on customer ID, or it can be on customer email as well. It's up to you. Or even if you do not decide customer ID, it is fine, because it is just a surrogate key. Okay, and I will simply name it as customer dim customers key. Perfect. Now let me just run this. Now let me just run this. Oh, yeah, we cannot just write something else before distinct. So let me just run this. Perfect. So now what you are seeing here, customer ID, but we have here one special column. It's called dim surrogate key. So what it will do, what it will do. Now let me just tell you what it will do. Now, when we will be creating our fact table, okay, so I told you in fact table we should not have anything else. So we will simply remove these three columns from the fact table and we will simply insert our dim customers surrogate key here in place of these three columns. We will just be having that surrogate key. I know now you have understood everything that I was just trying to explain in my slides, because obviously now you have seen that thing. Now how we will be just creating dim and facts, right? And this is the most important area, bro. This is the most important area. Data modeling, data warehousing, this is the most important thing. You can learn any tool, you can just learn anything, but data warehousing is like pure logical thing, bro. Pure logical thing. Okay, so now we have successfully built this particular table. Not really, this is just query. So now let's create a table on top of it. Okay, now let's create a table on top of it. So how we can just create it? How? So what you will be doing, we will simply create a table like with proper structure, like we'll be just defining the schema as well and everything. So let's actually do that, and then we can simply say insert into, because we need to just preserve, we need to preserve the data, right? We do not need to say, hey, create or replace. So I will simply create my table and I can simply say create table, and this time my schema is data warehouse dot, and I will simply say dim customers. Makes sense. Dim customers, and then simply we have customer ID. Customer ID is of int, let's say. Okay, then we have dim customer key, which is the most important thing. Dim customers key. Okay, and this is of int. Okay, then we have customer name, and this will be of varchar, or let's say string. And then we have customer email, and this is also of string type. Perfect. Let's create that, and once it is ready, then we can simply say insert into. Okay, and what we can do, we can simply run this query like this. Okay, or we can just create a temporary view as well on top of it, because it is very handy when we will be just applying any insert. We do not need to just use this whole query again and again. It becomes really easy. So we can simply create a view on top of it, and we can simply say create view, and view will be your, let's say, order data warehouse. Okay, order data warehouse dot view and underscore dim customers. Make sense? Make sense? Very good. Let me just create a view. Perfect. Now we can simply insert the values. So insert into order data warehouse dot dim customers key, not key, dim customers. Then insert into, and then we can simply say select asterisk from order data warehouse dot view dim customers. Make sense? Let me just run this. Now your dimension, first dimension is ready, bro. Ready. Congratulations, you have built your first dimension. Number of affected rows 10. Why? Why? We should expect 7, right? Let me just query order data dim customers. Okay. And select asterisk order data warehouse. View dim customers. Norm affected rows 10. Wow. And why? Let me just query this. Select asterisk from order data warehouse dot dim customers. Let's explore this. This is fun. Oh, why do we have this? Wait. Okay. I got it. If we just try to query this, if we just try to query the view, then you will see that thing. Select asterisk from order dim customers. Let me just query this. So this is our view, and this is actually returning 10 records, and this is not following this distinct function. And when we are just trying to query this, this is strange, and this is following that rule. No, not really. Why? Here we were just seeing 7 records before, but now we are not seeing. Something happened wrong. Let me just check. I think this is the issue. So what we can do, so what we are trying to do here, we are just applying distinct. Okay, and when we just comment it out, it will work fine. I think so. See, it will just say 7 records, but when we just apply row number and we have just applied distinct, then so it will not try to just eliminate the record. So what we can do, we can simply store this data in the subquery. So it is very simple. So I will simply remove this, and we will simply apply a subquery on top of it. And how we can just apply, there are two ways. Either you can use direct subquery and CT methods. I personally prefer subquery, so I will simply say select asterisk from, and I will simply use this as my source, like this whole table as my source. And I will simply say as t means like anything, like t dot asterisk. Then I will simply say this function. Perfect. And I will simply assign t here as well. So now let's try to test it. This should run fine. Perfect. Yep. See, so what we have done, we first concluded this result, and then we use this result as our source, and then we applied this column on top of it. That makes sense? Just the fundamentals of SQL, bro. Just the fundamentals of SQL. So now we can just create a view on top of it. This was just a hypothesis, and we can simply create a view here. And now this time we need to say create or replace view. Okay, perfect. Okay, now let me just try to recreate our dimension table, and before that we can obviously cross check that we have 7 records. Yes. So now what we will do, now you know that we have this table, so I will simply say create or replace table. Okay, now let me just say create or replace table. So this is an empty table. Okay, perfect. Now let me just say insert into. Okay, perfect. So this time we have finally 7 records. Finally. That's how you learn how to debug, right? So if you just see the dimension table, it looks perfect. Finally. So now let's create our second dimension, and now you will tell me what will be my candidate columns for second dimension. Just have a look for 3 seconds. Okay, I'm just scrolling in the data, and just tell me. Okay, time is up. So the answer is, the columns are product ID, product name, product category. So these are your next 3 columns that are eligible for next dimension, because that creates a different context this time. Make sense? And now you already know the implementation, like how we'll be doing it. So simply do it on your own and just tell me how was it going. Okay, obviously I'm there for you, bro. I'm just writing the code for you, so obviously you can just refer, but try to just make it on your own, bro. Just try it. It's not difficult, and you know like how to just debug the code. Okay, let's do it. So basically I will simply say create, first of all I will just try to add a heading, and I will simply say dimension dim products. Okay, now let's create dim products. So now we first need to create the product table. So it is simple. We will simply say create table, and table name will be data warehouse, order data warehouse. Yeah, create table order data warehouse dot dim products. Dim products. Very good. Products. Okay, then we will simply say product ID of int type. Then we have product name of string type. Then we have product category of string type. Then at the end we will add surrogate key, right? Dim products key. This will be of int type. Perfect, makes sense. Let's create this table. Product ID, product name, product category, products, dim products key. These are the columns. Let me just confirm. Yes, these are the columns. So now, you know the steps. Okay. Now what we need to do, we need to create a view on top of it like this. Now I will simply copy it and I will simply paste it here. And I will simply create view called dim products. Make sense? And we just need to change product ID. Very good. And I'll simply change name here as well. Product ID, and here it will be product name. Okay. Product name, and then it will be product category. Very good. Very good. Very good. Very good. And everything else will be same, I think. Not really here as well. I need to change product ID. Product ID. Very good. Let's create this view. Okay. And now let's insert the table within this, right? So in order to insert the table, like insert the data, we will simply say dim products this time. Very good. And we have dim products here, by the way. View dim products. Perfect. Let me just run this. Let me just run this and let's see the data what we have inside this. Select asterisk from order data warehouse and dim products. Let's see what we get in this particular dimension and how many records do we have. Oh wow, we have 9 records. Why? Because we have 9 distinct kind of product IDs, and obviously product names are distinct, but yeah, product category is repetitive. So I will just also give you a hint after getting the whole data model. So this is the candidate for Snowflake schema. And if you have already identified it, it's good. Otherwise, I will tell you, don't worry. And don't worry. I will just tell you. That is in the end of this data model. Okay. So now our dim product key is also ready. Okay, makes sense. Now let's create our third dimension, and it should be very obvious because now you know how to pick the columns. It should be very obvious. So this is my data. What should be my dim, like my next dim? Just tell me. Perfect. It is region ID, region name, and country. These 3 columns are my third dim. Okay, let's create it. Let's create it. So I will simply copy the table name from here, and this time we have region ID, region name, and country. Okay, let me just do it. Let's create a markdown first, and markdown will be having dim region, or let's say dim geography, whatever you want to keep. Okay, so I will simply say dim region, and we have region ID, we have region name, then we have country. Very good. And then we will be simply creating dim region key. Dim region key. Very good. Let's create this table. Let's create this table. Now we will simply create the view. Okay, makes sense. We will simply create the view for this data. Okay, and then this time we will simply say order by, this is my region ID. Okay, very good. And we will simply call it as dim region key. Bro, trust me, most of your interview questions will be revolving around these dimensions, facts, keys, surrogate keys, everything. Trust me. Trust me. These are more important than your tools that you learn. Trust me, bro. And the biggest advantage that you have is you can simply write, we have just built Spark, built everything in Spark SQL. That is the best thing. Dim region. Perfect. Let me just do it. Region ID cannot be resolved. Region ID. Oh, we just need to add, I think. Oh, thank you for this error because we were just using product ID. Okay, perfect. Now let me just insert the data. Okay, because then we will be having just last dim, that is date dim. So let me just do dim region. Perfect. And dim region. By the way, don't worry, I will just provide this notebook so that you can obviously practice, and you can just definitely flex this area in your resume because data warehousing is very much in demand, bro. It is a kind of niche that people are trying to learn and still they are learning. It is a niche. Okay, so this time we have 8 records because we have unique 8 different regions. Very good. So now, bro, Now you do not need to look at the screen. Now you will create the date dim on your own, because we just have one column in date dim, that is order date. So we'll simply create a dimension key for all the dates. Okay, so now let's create that. So I will simply say order date. Yeah, order date. Okay, simple. I will simply create another markdown and I will simply say dim date. Perfect. I will simply create the table called dim date, and I just need to remove everything because we just have one table, one column, order date of date type. Perfect. Yes. Let's run it. Very good. Then we can simply create our view. View will be very simple because we just have one column. So view dim date, then dim date key, then order date. Okay, here you will simply say order date. Now you will say Ansh Lamba, we have just unique dates. Why we are just applying distinct? For future. For future, because we don't know, like maybe we like next week we will be just receiving multiple orders in a day, right? That is why. So it is done. Let me just run it. Very good. Now let's insert the data into the dim date. Very good. So this is dim date. Okay, this is dim date. Very good. Our all the, hey, schema mismatch detected. Why? Why? Which schema mismatch detected, bro? Oh, I see. I didn't create the surrogate key, bro. Dim and date key. Thanks, bro. Let me say create or replace. Okay, now let me just rerun this view, and now let me just insert the data within this. Very good. This should return 10 records because yeah, we know that we have like unique days in our data. So our all the dimensions are ready. So now you know that this fact table, is as it is. Like the thing is, we have not created the fact table yet, but we call the master data as fact table in order to apply the joins. So this is my fact table, potential fact table. Let's say this is my transform data. Just to eliminate all the confusion, this is my transform data. Okay, okay, perfect. And here we have one dimension, second dimension, third dimension, fourth dimension. So in this transform data, what we will be keeping? What we will be keeping? We will just be keeping order ID, okay, which can obviously be replaced by order surrogate key, but we do not have much columns like textual columns for orders table. So we cannot like create a dimension on top of it. It doesn't make any sense. And by the way, that's called degenerate dimensions. Don't worry, I will just tell you about the types as well. Don't worry. So we'll just keep order ID. Okay, then we'll be just keeping here dim surrogate key for customers. Let's say dim customers. Then we'll be keeping here as dim products. Okay, then we'll be keeping here as dim region. Then we'll be keeping here as dim date. Then we will be keeping here as units, that is numeric column. And second one is revenue, that is also your numeric column. That's it. That's it. Because if in future I need to just turn on the lights, okay, I will just do it in just 5 minutes. So if in future we just need to grab these values like the revenue and all, we will simply use this table. Okay, and if we just want to perform any aggregation, that means if we just want to add a context on our aggregations, we can simply apply the join, okay, with these tables, and we can simply apply join on dim keys, and we can simply grab the desired columns. That is your dimensional data modeling. Okay, this step is very important. That's the step that I'm going to perform right now, because this step will grab all the keys based on the join. Just be with me and just see how I'm just applying join. So let me just remove everything. Now let me just write here fact table. Okay, fact table. So in this particular stage, at this particular stage, you will just bring in the keys. So how we can just bring that? I will simply first show you the query. I first need to bring what columns? What columns? These are my columns, right? I first need to grab order ID. Okay, then I do not want this, neither this. I just want directly these three columns: quantity, unit price, total amount. That's it, because these are the numeric columns. That's it. Okay, let me just first quickly write these columns: quantity, unit price, total amount. Okay, quantity, unit price, total amount. So I'll simply write order ID, quantity, unit price, okay, and then total amount. Very good. Very good. Okay, very good. Then what do I need? I need keys. So first key is dim products key. Second is dim customers key. Then we have dim region key. Then we have dim date key. Perfect. That is my table. That is my table. Now I can simply write the table statement, create table. Table name is order data warehouse dot let's say fact sales. Okay, and these are my definitions, and obviously I need to add data type for everything. Order ID is of, I think, int. Yep. And quantity, and these are, I think this is decimal, or let's say float, or decimal is fine. Decimal, decimal, and these are of int type. Okay, perfect. All the keys. Very good. Let me create this table. So our structure is ready. Our table structure is ready. Now it's time to feed the data. That is the logical thing. That is the logical thing. How we can just apply that step? And this step is called key staging. Key step, because we are just bringing keys. And how we can just grab the keys? We need to apply joins. We need to apply left joins. We need to just see which column is the mapping column, which column is the joining column. So first of all, I will just apply left join between your master data, which is having all the columns, with first dimension, which is your customers dimension. Then you will understand how we need to grab the key. I will simply say select f dot, what is f? Hold on, f dot asterisk, okay, or let's say f dot order ID, okay, then f dot your quantity, then f dot unit sold, units price, unit price, unit price, then f dot your total amount. Very good. These columns are coming from my master data, and these are the columns for my fact table. Okay, then I will simply say dc. What is dc? Dim customers. Dc dot dim customers key. That's it. That's it, because I do not want anything else. I will simply say from, okay, I will simply say from order data warehouse dot trans sales, okay, and I will just call it as f. Then I will simply apply left join, okay, and then when I'll be applying left join, I will apply with dim customers key, and I will call it as dc. Simple. Then I just need to define the joining condition. So my joining condition will be on f dot, what is the joining condition? User brain. User brain, let me just show you. User brain, it is very simple. So this is your table. Where it is at? Where's that? Yeah, this is your table. This is the main table. That is our source for fact table. We need to join this table with dim customers. What should be the joining key? Common sense. It is customer ID. Common sense. Customer ID. Okay, because when you will be applying join on customer ID, we will be able to grab the dim customer key. Okay, let me just apply that. Let me just apply that. I will simply say f dot customer ID equals dc dot customer ID. Perfect. Make sense? Let me just show you the output of this. What? Dim customers key. Oh, dim customers. Sorry, my bad. And what is the dim customer cannot be found? Dim customer or customers? I think customers. Yeah, dim customers. And dim customer cannot be found. Oh, really? Oh, because we did not define the schema. Orders, order data warehouse. And this is order data warehouse. Okay, silly mistakes. Order data warehouse dot dim customers. Wow, man. Wow, man. Oh, man. Oh, man. Oh, man. Cannot be resolved. F dot quantity. Oh, quantity. Quantity. This all happened because there's no light here. So just be with me. Okay, perfect. Perfect, bro. Perfect. So now, just see. This is my fact table when I just have one dimension. When I just have one dimension. See, I just have order ID, quantity, unit price, total amount. And instead of having those three columns, I just have this column, bro. Dim customer key. That's it. That's it. And if you remember, we had here 101. Okay, we have just one key for it, and for the redundant value we just have one. That means it is working fine. That means your fact table, this is your fact table, this is your fact table, this fact table is at the most granular level. See, 1 2 3 4 5 6 7 8 9 10, and it is grabbing the keys exactly that I want. Wow, now it's time to add more keys, same way that we are just using this. So what we will do, we'll simply add here, let's say dp dot product, dim product key, dim products key. Okay, then I will simply add dd, which is dim date dot dim date key, and I will simply add dr dot like dim region. Okay, dim region key. Perfect. Now we just need to add left join statements with all those tables. So left join with order data warehouse dot dim products. Very good. I will simply say dp on. Let me just have some more space. So on will be f dot products id, product id equals dp dot product id. Perfect. Now another uh, dimension, it will be order data warehouse, left join. Very good. Order data warehouse dot dim region, obviously dim region. Okay, dim region of dr. Then you will simply say on f dot region id equals dr dot region id. Perfect. Now last dim, which is your left join with dim date, order data warehouse dot dim date, dim date, and we will simply say dd on uh, f dot order date, I guess. Yep, order date equals dd dot order date, dim date. Perfect. Let me just run this query. Perfect, perfect. Oh, something broke because we are seeing 26 rows, right? Let me just check the join logic. Something is broken. Let me just remove this because I was just seeing a red mark here. Let me just run this alone. Dim date key. Yeah, let me just remove it from here as well. Okay, 26 records, still 26 records because something is wrong, I guess. Why it is giving 26 records? Why? So from transays, left auto join, dim customers. So till dim customers it is fine. Let me just remove this as well. And let's see what is wrong. So if it is running fine, let me see. Yeah, till here it is fine. Till 10 rows it is fine. Okay. So now we can say that we have successfully joined two dimensions. One is dim customers key and dim products key. So 1 and 2 dimensions are fine. It is too dark, man. Let me just turn on the light. And yeah, that's why like I'm not able to see. So products key and dim customers key, two dimensions are running fine. That's it. Now let's see let's try to add our third dimension, which is our dr. Okay, and before adding that, let me just try to query it how it looks like, man. Select asterisk from order data warehouse dot dim region. Let me just see. Okay, it is having 8 records. Okay, region ID is, oh, see what it has done. So now the thing is, if you have closely observed this, so our joining key is not region ID in this case, because region ID is 301, but for that we have region name. But in the same scenario we have country as well. Because country is more granular than your region. So what will be our joining key? Our joining key will be the combination of all these things. Now all these things, see, one is this, second is this, third is this, fourth is this, fifth is this. So now we need to just apply the join on this, or we can just use region ID, region name and country. So I will simply change the logic of my join on country. Okay, and I will simply say, that means order date is fine. Okay, so I will simply say left join. Okay, order data warehouse. So these are the steps that you need to just be careful. So dim region, and it will be dr, and join logic will be not on the region ID, because region ID is repetitive. Country is the most granular thing, right? Got it? This was the very good example, and I will just explain you, don't worry, after just applying this logic, like what exactly happened. Just be with me. So on dr, this is a very good example. I was not expecting this example that will come up, but this is a very good example. I will just explain you, don't worry. So country equals f dot country. Very good. Now let me just add here dim dr dot dim region key and dd dot dim date key. Let's try to run this now and let's see what we get. Let's see. Exactly. Finally we have successfully built our fact table. This is our fact table, in which we just have order ID that can be replaced with like dim order key as well. Not a big deal, but we do not have any text columns for that. That's why we have not created that. Quantity, unit price, total amount. Then we just have dimension keys, dim customer key, dim products key, dim region key, dim date key. So now if I want to perform any aggregations on top of these data, I can simply perform, and I can just aggregate and just add the context using these keys, man. This is finally done. And now let me just quickly tell you what exactly happened with dim region. So if you just look at the dim region table that it has created, we have used distinct function. So when it was just trying to apply distinct on this column, so obviously it has to apply distinct on this one and this one as well. So when it was saying 301, okay, this is distinct. North America, okay, this is distinct. So instead of having 2 records, we could have only one, but we had country. So within one region, we have 2 countries. I think this region is North America. Yeah. So in North America, we have 2 countries, Canada and USA. That means region ID was not the most granular level available. This was the one available for the most granularity. Okay, this happened. And this is a very good example. So now I'm very happy, and don't worry, I will just turn on the lights now because I was really excited to just tell you everything. So now you have successfully built your dim and fact, like everything. Like this data model is ready, and now you can see how it is transformed now. And now it is ready to be served to your data analyst, data scientist, and now people can build reports on top of it. This is done. This is done. Congratulations, you have completed your first dimensional data model. And don't worry, now it's time to actually talk about some more things within these areas. We will talk about types of fact tables, we will talk about types of dimension tables as well. We will actually talk about slowly changing dimensions as well. Wow, there's so much to cover, bro. Yes, but first turn on the lights, idiot. Okay. Okay, let me just turn on the lights and let's see all those things in the next few seconds. So bro, finally we have turned on the lights. You would have heard about types of dimension tables. Have you ever heard about types of fact tables? Have you? Trust me, bro. Just you. I know, like you wouldn't have heard about these terms. Don't lie. Don't lie. Okay. So this is a very rare scenario. Not very rare, because nowadays it can be like more common. So like, what are the like types of fact tables, and how can we have like types of fact tables? Like, we know that fact tables are just fact tables. Like, how can we be having so many fact tables, like types of fact tables? I know, so many questions. Let me just answer. So the thing is, first of all, let me just tell you what are the fact tables, or let's say types of fact tables that we have. Okay. Ooh. Ooh, nice. Okay, so first of all, we have first type, which is called uh granular. Oh, let me just decrease the size. It is blur. So the first type is granular, or let's say, why is coming blur, bro? Why? Oh, that's why. Okay, now it's fine. So the first type is granular, or let's say transactional fact table. This is type number one. Let me just explain this first. So what is this type of fact table? This is the most common type of fact table that we have. This is the type of fact table that we have recently created, in which we just keep the data at the most granular level. We do not change the granularity of that fact table. This is called transactional fact table, where one transaction equals one row. Simple. We do not change, we do not do anything. This is the most common one. Sorted? Simple? Yeah. Let's talk about the other ones. Okay. So the next type is next type is, it is called periodic fact table. Oh, what's that? What's that? Periodic fact table. So this fact table is also known as snapshot fact table. Snapshot fact table. Why? Because as the name suggests, here one record, one transaction or one record will not be equals to one row. No. Or let's say vice versa, one row is not equals to one transaction. No. So what we do, or let's say what people do, whoever creates this, whoever create this type of fact table, so they decide a period, let's say weekly, daily, monthly, bi-weekly, yearly. So what they do, we know that in the fact table, we can have like millions or trillions of records, right? So many records can be there. So what they do, they create a snapshot of a fact table where they aggregate the data. They can take snapshot maybe on a daily basis. Again, I'm just repeating that it depends upon the interval, it depends upon the period they are picking. It can be daily, it can be weekly, it can be monthly. Let's take an example of monthly. So what they will be doing, they will take the snapshot of the fact table every month, and define they will just define one row equals to many transaction, or let's say monthly transaction. Okay, monthly transaction. So earlier it used to be very rare scenario, but nowadays as we know that data is growing rapidly, so one row equals to monthly transactions, or let's say transaction, whatever you want to use. So these are the kind of snapshot that we create on top of our existing fact table. Make sense? Okay. Now third one is very very interesting. That is the rare one. That is the rare one. That is not very common nowadays. That is a rare one. What is that? By the way, it totally depends upon the business, because that can be very common in the organizations such as, I think, Amazon or Blue Dart, all those carrier. Yeah. So the third one is accumulating fact table. Okay, accumulating fact table. What does it mean? And really, this type of fact table you will not see everywhere in all the businesses. No. Now in this particular fact table, one row describes the journey or process. One row is the whole process. Let me just give you an example. So in these kinds of fact tables, we will be having so many date columns. Okay, so many date columns. Let me just give you an example. Just wait, I'm just adding my beautiful columns. So let's say this is my fact table. Okay, so in this particular fact table, I will be having so many dates, so many timestamps, which will be actually like explaining you the process, explaining you the journey, like which is taking in this particular fact table. Let's say, for example, you are using Amazon. Okay, so in that particular table, it can be like order ID. Okay, then let's say order date. Okay, order date, this is your order date. Then it will be like order confirmation date or order confirmation time. As you remember that whenever you just place an order, you will just get the confirmation as well. Okay, so confirmation, it can be in the backend on the Amazon side, because obviously Amazon is not selling anything like everything. Okay, so there are sellers who are selling. Let's say in their fact table there'll be a date called seller confirmation time. Okay, seller confirmation time. Then when it will be dispatched from the seller end. Okay, so that date, like dispatched date. Then collection date, maybe it will just arrive at the Amazon center if they are delivering. So they can be like so many dates, and at the end you will be having delivery date, or let's say delivered date. So every record is describing the journey of a particular product, of a particular transaction. So here one row equals to process or like the journey. So in these particular fact tables actually hold so many order dates, or let's say so many dates, not order dates. So another example can be, let's say, manufacturing company, where they know like raw material will come here, and then on this time it will be processed, and at that time it will be packed, everything. Okay, so these are your types of fact tables. If you didn't know earlier, see, there is something for everyone. So these were our types of fact tables. Now let me just talk about types of dimension tables. That part is really interesting because we always have so many dimensions, and we obviously have like lesser number of fact tables. Let me just tell you what are the types of dimension tables we have. So now let's talk about types of dimension tables. Types of dimension tables. So first of all, the very first type is, don't get confused between types of dimension tables and slowly changing dimensions. Though both are different areas, bro. And don't worry, I will also tell you about everything about slowly changing dimensions. Don't worry. Okay. So now let's discover our all the types of dimension tables available. So first type is conformed dimensions. Okay, this is the conformed dimension. Like, what does it mean and what exactly we need to just cover under this? Okay, so let's say you have a products dim. Okay, you have a dim products. Okay, dim products, very good. Now you have one fact table. Okay, this is called fact orders. Okay, fact orders. Okay, now you have another fact table which is called fact cancelled orders. Fact cancelled. Okay, make sense? Yeah, we can have like a different fact tables. Like if we have like everything, all the information available for orders, then we can also have like information regarding to cancelled orders, right? So in this particular scenario, just tell me one thing: will dim products be changed? The answer is no, because if my organization has like 10 products, like obviously then dim products will be same. So in that particular scenario, In that particular case, our dimension will be called as conformed dimension. Why? Because this particular dimension, this one, will be shared by more than one fact table. So this will be connected to this as well, okay, and this will be connected to this as well. Obviously many to one, obviously many to one. So this particular dim will be connected to this fact table and this fact table both. So in this particular scenario, this dimension will be considered as conformed dimension when one dimension is shared between multiple fact tables. Make sense? Make sense? Because but see, these things, why these things are important? Why? Because in the interviews, or let's say, yeah, in the interviews, let's talk about the interviews. In the interviews, interviewer will say, hey, just tell me about conformed dimensions. You will say, hey, conformed dimensions? I know about dimensions, but what is conformed dimensions? So that is the thing. These are the fundamental areas. Everyone knows, let's say, like this is a dimension, and we need to just create dimension like this. But you need to have deep knowledge. What are the types of conformed dimensions? See this. Okay, so this was all about conformed dimension. Let me talk about the second type of dimension tables, and this is oops. This is role playing dimensions. Okay, role playing dimensions. Wow, nice term. So role playing dimensions. So these kinds of dimensions are created when we connect our fact table with dimension table on multiple conditions, on multiple, let's say, relationships. What do I mean? So let's say this is your fact table. Okay, this is your fact table, this is your fact orders. Okay, this is your dimension, which is called dim date. Okay, very good. Now obviously we have here normal dims, like normal dates that we can have. Okay, normal dates. Okay, now let's say you have one column here called order date. Okay, now you have one more date column, one more date column. What it can be? It can be, let's say, cancel date. Okay, now, but you just have like one column here for date. You just have normal date, like for rolling calendar, right? So now for this particular fact table, you have built two you have built two relationships. Okay, one is this one, which is active. Okay, this is active relationship that is already built. One is inactive relationship. Okay, inactive relationship, yes. So this is your inactive. Let me just use a different color. So this is your inactive relationship. Yellow one is the inactive relationship, but whenever you want to use it, you can. You have the ability to use it. See, now this is saying, this is called role playing dimensions, because this dimension, this date dimension is playing two different roles. One role is for order date and second role is for cancel date. So when a dimension performs more than one role, then it becomes a role playing dimension. Okay, so you have one active relationship with order date and one is having inactive relationship with cancel date, but you have the leverage to use cancel dates relationship anytime you want. So that is called a role playing dimension. Make sense? Make sense? Make sense? Okay, makes sense. Okay, now let's talk about another type of dimension, which is called junk dimension. Wow, junk dimension. What are these kinds of dimensions? What are these kinds of dimensions? Let's say you have a fact table. Okay, Bro, let me just tell you one thing. If you would be just reading the book for these information, you would at least read 50 to 60 pages. Trust me. Okay, so if you're just getting this knowledge, just appreciate it and just take notes. So this is my fact table. Okay, so now in this fact table I have one column, or let's say two columns, like this and like this. Okay, and these two columns are related to, let's say, what should be the what can be a good example? Okay, so let's say in these two columns, one column is for a country. Okay, second column is for continent. Okay, okay, and obviously it makes sense that we can create a kind of dim region or dim geography. Now we know. Okay, now our data is just for, let's say, two countries, just two countries, that's it. Let's say my values is like country A, country A, country A, country A, and few B and B. That's it, just for two countries. And those two countries come under the same continent. And let's say my continent X, 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 X. So in this particular scenario, if I just create a dimension, how many records will I have? Only two? Only two records? Obviously, obviously, it will look like this: A, X, B, X. That's it. So this is called junk dimension. When we just have like 1 to 2 to 3 values in the whole dimension table, this is considered as junk dimension. Okay, this is a junk dimension. So when you just have like columns which are having flag values, that's it. So those are junk dimensions. Okay, very good. Now let's talk about the last type of dimension. It is called, yeah, this much of text size is fine. Okay, so this is called degenerate dimension. Wow. Mhm. Wow. And this is the word that I used when I was just building dimension and fact in the code as well. So what is this degenerate dimension? So let's say this is our fact table. Okay, and if in the whole fact table every dimension is already booked, everything is fine, but at the end, let's say we have just one column which says, let's say, let's take the same example. Let's say we have order ID. Okay, do we have any contextual value other than order ID? Do we have any contextual value? Do we have any order name? Do we have any order um anything like a relate any contextual value other than order ID? Do we have anything? No. That means if we will just create a dimension on top of it, it will just be having one column, right? Exactly. That's it. So that is called degenerate dimension. So in our example as well, when we were just having order ID column in the fact table, if I would create the dimension on top of it, it would be just having like only one column. That's it. This is called degenerate dimension, when we do not have anything to map with it. I do not have any order name and order blah blah blah. No, I do not have anything, bro. What I will bring after joining this dimension with fact table? What? Nothing. This is called degenerate dimension. Okay, make sense? Make sense? Make sense? Now it's finally the time to look at slowly changing dimensions. This is the OG. This is the most important thing, and you cannot build a data warehouse without slowly changing dimension, because the dimensions that we have built so far, if the values within dimension gets changed, how we need to tackle it? How? I will just tell you, don't worry. Now it's actually time to look at the slowly changing dimensions. Why do we need slowly changing dimensions, bro? So the thing is, we are just creating tables for dimensions, so we can expect that those values can be changed. Let's say you inserted some data today and it was fine, the categories, the products, everything was fine till this month. But after this month, we launched a new product. So how will we just tackling that scenario? How will we just inserting the new category? Will we be recreating the dimension table? No, bro. No. Okay, second scenario. Let's say your product name was changed next month. So will you be just creating the new fact table again from scratch? No, bro. No. So that's where we have slowly changing dimension in the picture. That's why. That's why. So let me just tell you one by one all the types. As you can see on the screen that we have type 0, we have type 1, we have type 2, we have type 3. So these are all the types available in the world of slowly changing dimensions. Now some of you would say, hey Ansh, we know that we have more types. Why you have not written it here? Don't you know about them? So the thing is, bro, yes, we have like more types. We have type 4, we have type 5, we have type 6, but we do not use it because it is very hard to actually manage those types. So that is why we do not take it in account whenever we are just learning, whenever we're just applying the knowledge. No. Same way, normalization, we have 6 normal forms, but in the real world we just apply till third normal form. That's it. Similarly, for the switching dimensions, we have type 6, but we just apply till type 3. And by the way, we don't even apply type 3 much. Type 3 is also a rare scenario. We just stay till here type 2. That's it. Type 3 is also a rare scenario, but you should know. You should have the knowledge of, like, you should have the knowledge till type 3. That's it. You should have the knowledge. So I will just try to explain this concept. Just try to be more focused right now. Okay. So let's say this is our data that is there in our product stem. We have product ID, we have product name, we have product category. Make sense? A common example, bro. Come on. So okay. So product ID means honey and product category for it is food. Product 2 is means shirt and clothing. 3 means com and clothing. Okay. So this is our initial data. Initial data that was there for 1 month. Now let's see, next month we have some changes. Now let's see what are those changes. That is our type 1. Ansh Lamba, where is type 0? So here is the good news. Type 0 means there's no change. So yeah, type 0 means no change. So it is type 1. Type 1 is most commonly called as upsert, as you can see. Oops. It is called as upsert. Upsert means update plus insert. Okay. Yeah. This is not invented by me. This is not my personal word. This is the word that we use in the industry. Upsert. So what happens? Okay. So this is my product. Okay. That is here. Now. This was our initial data. Okay. 1, 2, 3. Honey, shirt, comb. Makes sense. But next month we got this data. 1 is for honey, second is for shirt, 3 is for com. That is fine. But if you just check the product category, now they have changed the product category. Maybe they have just added one specific category that is for hair. Now you do not need to map your data with clothing. So in this particular scenario, we use type 1 slowly changing dimension, which is called update plus insert. Now Ansh Lamba, fine. We understood the concept. But what is this update plus insert? Now, like how we need to implement it? Concept is very simple. So this is the kind of formula that you can just keep it in your mind. Okay. Whenever you are having existing IDs or existing primary key, you just need to update the values. Again, whenever you have existing values, you just need to update the values. If you have new records, then you will insert the data. Don't worry, I will just show you practically as well. Then you will just keep everything in your mind. Okay. So before that, just try to understand the concept. So now in this case, as we know that product ID 3 was already there. So if it is changed, if it is like now this, so now what we will be doing? We will simply update the product category. That's it. We do not worry about our previous category, whether it was clothing, we do not worry. We just need to keep this product category. That's it. That's it. Make sense? Obviously, why we just need to just worry about it? Why? We do not need to worry about it. Okay. This is your type 1 update plus insert. Simple? Yes, it is simple, and that's why most of the industries use this. Okay. But in some scenarios, companies or organizations need to preserve the history of the changes as well. In some business use cases, teams, departments, let's say finance team, needs to identify what was the previous record. They just need to look at the history. How they can do it. So in this, we achieve this particular scenario using three additional columns. Yes, whenever we create dimension table, we add these three columns on top of it. One is effective start date, second is effective end date, and third is in use. In use means if this particular value is in use right now or not. So this was our initial picture of the data, right? This one. So what we did, we added effective start date. Effective start date can be the date when we actually created the table. Make sense? Okay. Now effective end date. Oh, sorry, effective expiry date or end date is same thing. Ansh Lamba, you have just mistakenly put 3000 there. No, that was not by mistake. So what is the expiry date? Our expiry date is, let's say, a very huge date because this product is not getting expired. Make sense? Make sense, because these are in use. It is saying yes, that means expiry date is like in 3000. It is not expiring. But now we know that we have made a change. So now just see this thing now. So what we have done, these two records are fine. For comb, we have inserted new record. Why? Because the previous record says that it is of no use now. Say no. And now you will see the expiry date as well. Expiry date is 2nd of January 2024. Okay. 2nd of January 2024. And instead of putting 3000, now we know that it is expired. Now in the next line, we are saying in use equals to yes. And again, expiry date is like too far from now, because obviously it is not expiring. So that is the concept. So now with the help of this slowly changing dimension, we can actually track all the changes of a dimension. Okay, make sense? Make sense? Very good. Now let's see the type 3. So type 3 will not track your all the history, but it will just track your previous record. That's it. That's it. So as you can see, like this is our previous picture of the dimension. So after the change, you can simply see we have added one column. It's called previous product cat. So if no change is there, obviously both the values will be same. This equals to this, this equals to this, this equals to this. But we know that we have made a change in com. Then you will see something else. This is com, product category is here, but the previous value was clothing. So in type 3, we preserve the previous value. That's it. That's it. These are your types of slowly changing dimensions. Type 0, that means no change. Type 1, update plus insert. Type 2 will just add your effective start date, effective end date, and expiry flag. Then third is just previous value. That's it. This is the most complex topic of data warehousing that you have understood like this. This is the most complex topic. Just try to ask someone, hey, just explain me what is type 3 storage in dimension. So now you have understood like this, but that is not the end. I will just show you how to just let's try to create slowly changing dimension type 1. Okay, let's try to practically see how we can just build slowly changing dimension type 1. Let's see, because I want you to learn everything. Okay, let's see. So now it's time to actually implement the slowly changing dimension. I will just try to make you understand Like at least you will be able to build slowly changing dimension type 1. Okay, so just be with me, I will just tell you everything. So now let's recreate one database. Okay, and I will simply say sales SCD. Okay, because I'm just creating this database just for this particular purpose. So I'll simply say create database SCD, and again I'm repeating, if you will be just recreating this cluster, it will just terminate your existing databases. So then just make sure every time you just reconnect, then just recreate a new one. Okay, so just keep this thing in mind. Then I will simply say sales SCD. Perfect. Let me just create this table, and it will simply create the table for me. And don't worry, I'll just like wait. Let me just show you, because I don't want to give you the spoilers. Okay, so perfect. Our table is almost ready. Very good. So now let's try to insert 10 records. Okay. Now. Oops, I didn't change the schema name. SCD. Let's try to insert 10 records. Okay. So this will just insert the 10 records. Okay, very good. Now let me just tell you what it has done. So let me just create a new cell of markdown, and I'll simply say SCD type 1. Very good. So what I will do, I will first of all show you the source. Select asterisks from sales SCD, then dot orders. Okay, let me show you. Sales SCD, order or orders? I think orders. Yeah, perfect. So now this is our table. Okay, this is our table. Now let's try to just fetch the columns which are for products only. Okay, product ID, product name, and obviously product category. Okay, product ID, product name, and product category. Make sense? Make sense? Make sense. Okay, so now in order to apply a slowly changing dimension, we first need to create a view, okay, on top of this particular dimension, which is this one. So now let's try to do that. So what we will be doing, we will simply say select distinct on product ID, product ID as product ID, and then product name. Okay, then we will be having product category. Okay, perfect. So now this is coming from sales SCD dot orders. Okay, that makes sense. Let me just see what do we have. I think we would be having 9 records. Yeah, so we are having 203, 208, 205, 209, 204, 206, 207, 202, 201. Perfect. So now when I will be creating a dim on top of it, okay, so what I will be having, this thing. Very good. Let me just quickly do that. Let me just create table. Okay, create table, and I'll simply say SCD sales SCD data warehouse dot dim products. Okay, so we are not creating the surrogate key right now because I just want to explain you the concept of update plus insert, but you can just definitely try it as well. So dim products. Okay, very good. Now we know that we have 3 columns, product ID, because once you understand this concept, that means everything is fine. Now like you can do anything. Product ID, product name. Oops, I just ran it by mistake. Product category. Very good. Let me and string, and then this is string as well. So very good. Let me just run this. So what is the name? Okay, we can simply say sales SCD. Okay, not a big deal. Not a big deal, bro. Not a big deal. So we are just saving the div in that particular database. Okay, so this is done. This is done. This is our initial load. Okay, this is very simple. You would say, hey, Ansh, we know that. We can simply do this. And you will just say select asterisk from sales scd dot dim products. That is fine. Yeah, I know. I know that is fine. Okay, that is fine. But yeah, because we have not inserted the data. So let me just insert the data now. I will simply say insert into, and this time is sales scd dot dim products. So by the way, who will write insert into? Like select asterisk from sales scd dot orders. Let me just run it. This auto suggestion by Databricks. Okay, find duplicate column in the data. Duplicate column. Found duplicate column in the data to save. What duplicate column, man? What duplicate column? So let me just say create or replace. And now let me just try to recreate it. No? What's wrong? What's wrong? What's wrong? What's wrong, man? What's wrong? Sales dot orders. Sales SCD. Product ID, product name. Oh, I see. So it is saying that you cannot pick all the columns. Obviously, that makes sense because we just need to pick product ID. I was like, why do we have multiple columns? Product name and product category. Okay. Now it is fine. So let me just show you the dimension right now. And I know that it's not a big deal that we have, let's say, 10 records or let's say distinct. Do we need to add distinct? Did we create any view? Did we create any view? Oh, that is why we didn't create any view. So let's create a view here. So create view, and this will be like sales scd dot view dim products. That makes sense because I want to keep everything aligned with the previous approach so that you can just feel that okay, we have these things as so. Yeah, now we will simply say this time create or replace table, and this time we will simply pick view dim products. Very good. Now we should just see 9 records. That makes sense. Yeah, and let me just show you the table. Now you would say, hey, this is not a big deal. Like we can just see 9 records. So big deal is the next step. So now this is our initial load. Okay. So now let's say on the next day, we have some changes. We have some changes in product ID. Let's say we change something. Our 201 ID product name is like gaming laptop instead of laptop. What should happen? It should update this information in the dims table. According to the rule of SCD type 1, upsert, update plus insert. Now let's say we have a new ID. We have an ID called 230 and that has product name such as let's say airports. Okay, airports. Let's say airports and obviously electronics. So in that particular scenario, it will insert this new record. Do you want to test it? And do you actually need to see like what will happen? First of all, let's insert some new records. So I will simply go to insert into command and I will insert new records. So as you can see, these are my 10 records and I can simply copy these two values like this one. Okay, now let me just add these two records. It will be fun. Let me just show you, bro, because today you will learn everything. Okay, now let's try to add something called as 201. We need to just rename it as gaming laptop. Very good. And let's add another, yeah, here. I will simply say 230 and I will simply name it as, let's say, airports. Perfect. And let me just change the date as well. As we know that the last date was 10th of February. So this will be 11th and 12th so that we can only read the incremental data. Okay. So this is fine. So let me just let me just insert this data. Okay, yeah, let me just insert this data to our source. Perfect. So now our source will be having 11 records, obviously 12 records, obviously 10 plus 2, 12. But now we need to just make a small change in our view. If you have carefully observed or carefully learned everything from this video. So we are just reading data incrementally. So now our view will be only reading the data where order date is greater than 2024 0 to 10, so that it can just bring all the data. So we will simply say create or replace greater than this date. Now do you want to look at the view? Let me just show you. So I'll simply say select asterisk from sales scd dot view dim products. Very good. So this time I should only see 2 records because 2 are the new records. Very good. So now this is fine. This was very simple. Anshlaba, now let's just tell us how these 2 records will not be inserted into dimension, but only one record will be inserted, which is new one, this one, and this one will be automatically updated. How? Let me just tell you, bro. So we have something called, let me just first create a heading. I will simply say merge scd type 1. So we have something called merge statement. Okay, so we to scd type. Okay, so we have something called merge statement. So what we need to do, we will simply say merge into. Now let's just tell me in which table we need to merge, in which table we need to actually see the final results. Obviously dim table, right? We will simply say sales std dot dim products. Simple. And we can also use alias for it because as it is our target table. Then we need to add something called as using. So this is our target table. What is the object? Either it's a view or table which is actually merging the data. It is view. It is our view. So we will simply say sales scd dot view dim products. Makes sense? View dim products. Okay, perfect. And this is our source. We call it as our source. Very good. Now it is saying that, okay, what is our joining condition? What is the joining key between both? Obviously product id. So let me just quickly write target dot product id. Yep, equals source dot product id. Very good. Now is the thing. So once it is matched, once target product id equals to your source product id, then we need to update it. So we will simply say when matched, then update set asterisk. What does it mean? When matched, then update set asterisk means all the columns should be updated. But when not matched, then insert asterisk. That means if it is not matching, the product id is not matching between the target and source, then insert all the new records automatically. Now I'm going to just run this. Let's see dim products. Obviously dim products is not there, it is dim products. Okay, now let's see. Now if all the logic is correct, then I should only see 10 records instead of 11. Let me just see. Let me just see. Let me just query my dimension. Selected asterisks from sales SCD dot dim products. Let me just see. Very good. Very good. We do not have 11 records. We just have 10 records. And this is your new record 230, and this is your 201, which is changed from laptop to gaming laptop. We have successfully implemented slowly changing dimension type 1. Congratulations, bro. Congratulations. So, in this particular video, I know we have learned so much, and I know you are all set with your fundamentals, and I know you have learned so much. And, and I am really proud of you that you liked the video, because I know you have already hit the like button, because obviously the knowledge, the practical examples that you have seen so far, obviously you are forced to just like that video, but I want you to comment on this video as well. Why? Because it will be very helpful for others, because when they will be seeing the genuine review, they will actually feel okay that this is a video they should just watch, obviously. Okay, and one last thing before ending this video, I will just take you to my YouTube, and I will simply say Ansh Lamba, and I will just ask you to ANSN H. So just click on this join button. Just click on this join button. Just click on this join button and just do support this channel. Do support this channel, because if you just want to pay $1,000, you are open to just do that, bro. Just open. You are just open to do that, and obviously the knowledge you will get in return, you already know that, like what they are doing. So if you want to just support this channel so that I will be just continuing making these kinds of videos, just click on this join button and happy learning. So just click on the video coming on the screen, and I'll be seeing you there. Bye bye.